Good morning, colleagues. How are you?
Good morning, Doctor. Trying to survive after a long week.
Yeah, I know the feeling. Okay. Yeah. All right. So I've just phoned security to complain about some uh, taxis parked outside the entrance of the university, which are blasting music out and making my windows rattle. So anyway, I think they've switched off the music now, which is good. I've got very low tolerance for very loud music in the background when I'm trying to do something. All right, so good morning, everyone. Today is our last contact session, but let's see how we go. I've got into a position where I need to cover material from contact session 5 and 6 in one session. And I don't, yeah, so let's see how we go. We're going to have some breaks today. So I've got three kind of main components that I want to cover during the session. And then when we get to the end of this morning session, which will end at 12, um, if you feel like we need another session, we could possibly arrange one, but depending on how you feel about it. Okay. So I'm quite happy to meet. I could meet on a Saturday morning again, next week or the week after if necessary. All right, so I'm going to start the presentation. I'm going to be toggling between different things today. So I'm going to be showing you different things just to kind of explain how we do um, things for qualitative analysis. So, sorry, I'm saying quantitative. I'm starting to say qualitative. I should be saying quantitative. Okay, so this today's session, we're going to be, well, the first component of today's session, which would have been contact session 5, but I was running behind, is going to be data capture analysis. Sorry, just to say as well, there are some extra slides on the last session, which I'm not going to go through because I think you have a good understanding of when I asked you questions about questionnaire design, for example, you mentioned piloting, you mentioned ethics, making sure that you cover ethical issues on the questionnaires. Um, so I think you've got a good understanding. So just look through those. It's just some additional criteria that you need to think about and take into account when you're designing a questionnaire. But I want to move on to to collecting and capturing data and so on. I'm not going to focus too much on collecting data because that is something which there's lots of different ways of doing that. And there's lots of different contexts. So I'm mainly concerned about and also it's probably because it's not something that we do, that we get involved with directly at StatCon, except for supporting students and staff with online surveys. Um, so, because usually the researcher themselves is responsible for collecting data. It's not something that you can contract it out to other people. But and some students have done that. I've helped a couple of students who've paid. There are companies out there that collect data for people. And in fact, the online survey software we use, that company has a sort of international database of people that you can sample from. So if you can pay them to actually find you a sample. But most research, and I would sort of also say that most research, your sample and population is so particular for your project, that it might be that those kinds of organizations might not be able to help you with a sample that's relevant for your research. So usually it's something that you can sort of manage, the student can manage on their own. All right, so we're kind of moving towards the data collection. We're kind of moving beyond the design phase, and we might have designed a data collection instrument, and now we've reached the point where we can go into the field to collect data. So we're going to collect data and we're going to analyze and interpret that data. So that's the sort of focus of this last contact session. It should have been contact session 5 and 6, but as I said, I'm running a bit behind. Okay, so this for field work. So this is we're talking about data collection. I'm going to skip this slide because I need to move quite quickly through the content. If you want to share any stories about your fieldwork, you're welcome to. But I'm going to skip a few slides today just to go through. I need to get through the material if we can. So one of the things that obviously you need to, when you're doing your data collection, you need to reflect back on the goals of your research. And you need to sort of obviously take into account your research questions and so on. So it's important to, so you're not going to leave that part of the research behind. You're still going to be focusing on what the problem is and how you're going to investigate it and so on. So the research design and the conceptualization of your study is still there when you're collecting data. Yeah, so some of the problems that we've observed with, I haven't necessarily experienced all these myself, but I have seen other students experiencing them. One problem might be that the student can't get the necessary permission to proceed with the research. So the plan had been that the student would go to company A and sort of conduct a questionnaire there. But when they get there, they can't. The permission is withdrawn, so the student can't get access to the sample that they were expecting to. And then also the second point is related to that is that the plan might have been to sample first-year students, but then suddenly that sample is not available. I've got a nice example of that. It's not that the student can't get access to it, but the group that they want to access will only be available next year. So the student is targeting different types of trainee nurses in different hospitals. And the one group is only going to be accessible next year. So the question that the student needs to ask is can they work with a sample that they have from this year? And then have they got enough time to wait till next year? And that might not be sort of a sensible thing to do in terms of how much time they have left to do their research and so on. So lots of things can go wrong with the third point is a very common one where the student sort of says in their proposal they're going to sort of sample 300 people and then suddenly they only get 50. And then how do you deal with that kind of scenario? And I've had two recent cases where the students have proposed a bigger sample and they can't seem to achieve that sample size. So what do they do? And then you have to ask the question, can you continue to do the analysis that you wanted to do with the existing sample size that you have? And usually it is, sometimes you can do it, but sometimes the research is compromised. And that's why I think I mentioned at the end of the last session, so that's why mixed methods works quite well, because if your kind of quantitative component fails, or isn't as strong as you would have liked it to be, you've still got that qualitative to fall back on. But if your study is purely quantitative and you only get 10 cases, 10 responses, then you've got a real problem because your kind of result doesn't match your design. Yeah. So then the other point is students leave their fieldwork very late, and that puts a huge amount of pressure on the remaining stages of the research. And we see that a lot as in StatCon, we see that a lot. So I've recently had a situation where the student approached us at the beginning of September and hasn't started collecting data yet and wants to hand in mid-October. And that's the timelines are far too tight. Okay. Fieldwork can take longer and can cost more than anticipated. So that's another problem that can occur for students. Then the student might be using a data collection instrument that's not suitable for the target sample groups. We've kind of spoken about that already. And then important information is lost during the fieldwork phase. So students can lose their data. I think it's more difficult today, but although it's not necessarily true either, because I've heard of situations where students have had sort of a box of questionnaires in the boot of their car, and then their car gets stolen, so they lose their questionnaires. So that can happen. The other thing that can happen is not so much during the field work, but if you're writing up your dissertation, for example, and then your computer crashes and you can lose your work. So that those kinds of things can also happen. So it's just trying to mitigate for those kinds of problems. So yeah, so these are some of the things that can go wrong, and it's trying to mitigate the problem happening in the first place, but then also how do you deal with the problem when it happens? So how do you sort of support the student when they're experiencing these problems? Because it can be quite devastating at times. Okay, I'm going to skip this slide. Okay, so the data capture is the data collection is often the student has to perform that. Sometimes they can get support, and those are some of the things that obviously most of the time hopefully it works well and goes well, but at other times things might go wrong, in which case you have to try and help the student get through those problems. And there usually are ways that we can help students get through the problems. All right, then, so I'm going to skip this. And then, yeah, so when we come to data capture, this is when you've actually got the data and you need to then capture it. You need to get it into a format which is analyzable. So we want to have information. So you might have used questionnaires, and then I've just thought of something sorry, I left my notes at home, which wasn't very clever. To make some new ones that I'm going through. So just go through this. Right, I'm just making a note for myself for something that I want to show you later. So when we collect data, whether we're using a questionnaire or some other kind of data collection, we need a code book. The code book is what it's basically gives you the link between the variables that you have and what's in the data set. So and the reason why we need a code book, and you'll see when I show you an example, it should become clearer. When we have data in an Excel sheet, for example, in a stats program, it's presented in number form, so we can't always see the labels that go with the answers that we've got from the questionnaire. And I'll show you an example of this shortly. So there's a disconnect between what we see in the sheet and what information we're actually using. And the codebook helps us link the questions that we have in the questionnaire, for example, to the data that we have in the data set, and it gives us more information about that data. So, for example, if we have a column of male female, where we've coded male as 1 and female as 2, the code book tells us what that 1 is and it tells us what that 2 is. And I'll give you, when I show you the example, it should become clearer. And it's quite important to have, and it's also important for audit purposes. So if somebody else needs to use your data or needs to check your data or look at your data, you can't just give them, it wouldn't be a good idea just to give them an Excel sheet with lots of 1s and 2s and 4s and 5s in it. They need to know what those 1s and 2s and 4s and 5s mean. Yeah, so some issues. So if somebody gave me a data set which was just numbers to analyze, I would need a code book or some kind of link to that data to be able to work out what the data is saying. So you need that code book. So sometimes there's no code book, so a student will just send you data without any information about it. And then the second could be that there's a poor quality code book, so they might have got the coding wrong or something like that. And then that means that you might end up identifying the wrong label with the wrong number, for example, which is also, that can be a critical problem. So when we have a technical assistant who helps prepare data sets, and if he makes a mistake and we don't pick it up, you could end up with data which doesn't actually reflect what the original data should be reflecting, and that's a serious problem. Okay, data capture errors can be made during the data capture process. So that's where the student is, if they capture data themselves, they make a mistake, and then you end up getting bad quality data because it's not accurate, it's not representing what was originally measured. Not all data is captured, so you've got incomplete data. It wasn't an example of not being captured, but somebody gave me a data set which wasn't complete because they hadn't given me the most recent data set from an online survey. So that means you're not going to have all the data that you need for the analysis. Cases to be excluded or included in the data set. So when you're doing your research, you're going to have inclusion and exclusion criteria. And sometimes people will answer a questionnaire even though they're not meant to, and then you'll end up having those people in the sample when you don't really need them in the sample. So that can also happen. You can end up with the same records being captured multiple times. And so you end up with repeated cases in the data set, and that can be when I first started working on survey analysis. There was a professor in another department who used to do a lot of quantitative research, and he accidentally kind of combined the same file twice, and ended up with double the amount of records, but they were repeating the information. And that can happen. Those kinds of problems can occur. I've also recently had a case where a student handed in her data, and I don't think it wasn't a thing that she did. It was, I think the participants that she invited to participate in the survey misunderstood what she was asking them to do. So what they did was let's say there were 50 employees at the organization, one person would give an answer, and then they copied that answer for all 50, sort of assuming that it was fine to allow that one person to represent the organization. So she had replicates, hundreds of replicates in the data set. Most of the data was a replicate, so she's had to go and recollect. She had to go back into the field to collect accurate data. Then data can be captured in the incorrect structure. So you'll see when I show you the data sets, there's a format that we use for the data. So for example, the variables are in the columns and the cases are in the rows, and that's how we structure the data for analysis. So if you do it the other way around, we can fix that. We can correct that, but ideally you want the data to be in the correct structure. And I think I've got some notes online about that. And then data can be captured in incorrect format. So for example, you'll see with the example that I use that the original data is in Word format, but we need it to be in numeric format, so we convert it. And I'll show you that conversion in a second. And then something else that can happen is when you cutting and pasting data. So for example, we need to get data from Excel into SPSS, for example, for the analysis. And if you're using cutting and pasting to do that, if you align incorrectly, you can end up with data, with bad quality data as well, because the data will be in the wrong position. Okay, so those are some of the problems that can occur. And they don't occur a lot, but you have to look out for data all the time because of these potential problems that can go wrong. Okay, and then the last problem, which is very rare in my experience, is that students make up data. We have seen it happen. We've had a few cases while I've been working here where the student has fabricated data. And what we do there is because we're not sort of the supervisor and we're not the faculty, what we do is we report the incident to the supervisor, and then they must take it to the faculty. Sometimes you also need to be careful, though. I had a colleague who was convinced that a student had fabricated data, but she hadn't actually fabricated. She just captured the data. She hadn't understood how to capture the data correctly, and she captured it in a very unusual way. So it wasn't. She hadn't made up the data. She just captured it incorrectly, and so it looked like it was fake, but it wasn't. So you have to be. I never make assumptions that the student has fabricated the data until I've done a proper check of the situation. But and it's not often. It's a very, very rare thing that would happen. It's also quite difficult to fake data as well, because there's all sorts of ways we can identify it if it has been made up. So it's not that easy to fabricate data. Okay, so just yes, but it's something that as a supervisor you need to be aware of, that if the student's getting desperate, they might want to. Okay, I'm just going to toggle out of here now. I'm not going to use that as an example. I'm not doing this either. Okay, so just to go through, I need to make a note about this slide. Blueprint. Okay, and then I'm just going to go forward here. All right, so how do you capture data? The student can do it themselves using an app in the field. So if you've got a online survey, for example, you can run those online surveys on phones these days. But there's also some entities have you could use a tablet, for example. So you can set up the questionnaire online on tablet format, and then you can actually capture the data while you're in the field. So it's usually an organization that does that, but there's no reason why a student wouldn't be able to if they're doing their field work. It depends on how they're administering what they're collecting and how they're administering it as well. You can also capture data yourself by using Excel, SPSS, or Epidata, and I'll show you Epidata in a second. And I'll explain why we use these different applications. Excuse me. And then you can also use an online survey. The data, when you do an online survey, the data is captured obviously by the company that's running the online survey, usually in the cloud or on a server. And then you need to extract the data from the online survey. So usually there's a way you can download the data, usually in an Excel format or a comma delineated format. Some programs like the one we use actually export to SPSS directly. So you don't have to, but you still need to do some editing of the data file once you get the data file. Okay. And then if you're not going to do it yourself, if the student's not going to do it themselves, morning Mfuno, then you could get somebody else to assist you. So for example, StatCon assists students with online surveys. You can also get a professional data capture to help you. So for example, we have an in-house service where we have a lady who's a trained data capturer. So, and we've got a couple of projects at the moment where the students got sort of 300 questionnaires, and Tabile captures the data for the student. Yeah, and I'll show you kind of how we set up those things now. But it's very important to achieve accurate data capturing. You don't want to get, because you're basically transferring information from some kind of data collection process into a format that you're going to use for analysis. And if there's mistakes made, if you end up with information which is not the same as you have on the questionnaire or on that original data collection tool, your results, your analysis is going to be inaccurate, and that's very, very problematic. Okay, so I'm just going to show you a couple of examples of how to do these things, let me just share. Okay, let's look at. I just need to go. Okay, so just using this is just an example of an Excel file. I'm just showing you this to show you what the original data looks like, and then what the actual data we start using looks like. So this is from an online survey. The researcher here used an online survey to capture the data. So basically, these are the columns. This is the format that we use for analyzing data, where the columns are the variables. So for example, this question is, how long did it take you to complete the course? This study is looking at sort of evaluating a course that was done, a short learning course that was done. How long did it take you to complete the course? Less than 3 weeks, more than 3 weeks. So that's one of the variables. On a scale of 1 to 5, the question is not showing here. I think they used Microsoft Forms for this. So this is not showing. This is what I mean when I say you need a good code book, because this extraction doesn't show you what the actual question was for this variable here. There would have been a question here, and we'll see. I think we'll see what it is on the next slide. Or I can find it from what I've done here. So this is what the raw data looks like. You can see it's in Word format. So it's giving you the response options that the person gave when they answered the questionnaire. So this person said they neither disagree or agree with the question about whatever this question was here. Okay, so we can't analyze using these words here. So we need to convert the data into a numeric format. So this is what this next folder here shows you what the data would actually look like when we work with it. So so this question B2, which was this question here. This will be B2 here, I think. Will it be? Let me just check. No, sorry, this is B3. Okay, so B2 is this question here. This will be question B2. How long did it take to complete the course? And there's three possible answers here. Less than 3 weeks, more than 3 weeks, and less than 10 weeks, and 10 weeks or longer. So that variable there is converted into this column here, which is, so it's going to be question B2. And these are the response options which have now been converted into a numeric format, which we can then actually use for the analysis. And we'll reattach the variables, we'll reattach the labels later on when we run the data in SPSS. So that's, so we have to get the data into this format in order to import it into a program that we can then use for analysis. And it might seem, if you haven't done it before, it might seem like a laborious process, but it doesn't take that long to convert the data. And once you've got it in that format, it's very quick to analyze it. So it's not, you need to know how the process works, but it's not actually that difficult to apply it. And then some of the questions are open-ended questions. So for example, this question D8, I can't remember what the question was. It'll be over here somewhere. It might not be. It's what aspect of the course helped you the most? That's the question. So the person here said, I learned how to critically think and how to research with, I'm not sure what tuition is, and write my projects correctly. I think this might have been tuition. So that's the open-ended answer that the person gave to the question. And we don't code those. The researcher can code them later if they want to. But when somebody gives an open-ended response to a question, we import it in the format that it's in. And I think at the end of the last session, I mentioned I've just learned about a program called AI Allies or something like that. And apparently this program will allow you to code these responses using AI kind of technology, which is quite interesting because it's always difficult to know how to deal with these open-ended questions, and especially if you've got a lot of cases. If you've got a few cases, it's not so bad because it's not that time-consuming to go through them all. But if there are kind of automated processes that you could use to analyze those questions, because there's a lot of answers. There's over 600. In fact, this is the data set. There's over 1,000 responses here. So to go through those one by one to code them is very laborious. So definitely to find some kind of automated system of doing it would be good. Okay, so what we would then do with this data set is we would import it into SPSS, and then we'd reattach the labels in SPSS, and then we would then do the analysis of the data. So that's the kind of process that we would follow for an online survey, if the data comes from an online survey. Okay, I'm just going to stop sharing this screen. Another process would be to use, I just want to show you this code book quickly. So this is, so talking about code books, so the code book is basically telling you what variables you have in the data file and what the question is and what the labels are. So this is an example. It's a form of a code book. It's called a draft questionnaire framework. This is from Prof. Vanessa Sherman. But so you've got your construct here. The construct is, in this example, is professional development, improving practice. There's the definition of the construct. This is the number of items that are going to make up that construct, 26. The item type is dichotomous items, Likert scale type. And then usually in a code book, you would have all those items listed as well. This is just a summary of the constructs that you're going to have in the questionnaire. This is the coding: no equals one, two equals yes, four equals strong, one equals strongly disagree, two equals disagree, three equals agree, four equals strongly agree. So they've got two types of scale for those items, which is a bit unusual. And then frequencies, the possible analysis would be frequencies, cross tabulation, scale analysis, reliability analysis, and correlations. So that's kind of just summarizing what you have for that variable. So if somebody gave me that file without telling me what the questions are, so for example, that one question where I couldn't see what the question was because there was a long introduction, you'd need something like this to be able to link back. So I was able to work it out from the questionnaire that the researcher gave me. So I could look at the questionnaire and say, that's what that question was. So I can label it correctly. So that's how we make how we prepare the data. And this is you need this framework so that you know what's what in the data set. Okay, and then if you have collected data using questionnaires, and I just need to find this program here. Okay, that didn't work. Sorry, stop sharing that again. It's not sharing the window that I wanted to share. Let's try this again. Oh, that's interesting. Okay, I'm just going to close this file down because it's not allowing me to open the other program. Let's just see if that works. Let's try again. No. Okay, it's not. It's very interesting. I had this problem before. Let's close that. I'm going to try and force it to. Nope. So it doesn't want to load this program. I'm not sure why. Just try and close this down. I don't really want to do this. Try this. Technology, when it doesn't work, is not fun. Oh, there we go. Okay. So I don't know if you can see on the screen, there's like a form. Just see what you're seeing here. Okay, sorry, can you see like a form on the screen?
I can't see anything yet.
Okay, so let me just, yeah, it's not showing this program. Just try again. Okay, otherwise I'll just explain it to you in words. It doesn't seem to want to display this. So sorry, what I've got here open, which is not displaying, and I'm not sure why, because I have done it before. It's a program called Epidata. It's a free software application, which we use for data capturing. So the reason why we don't always use something like, so you could use Excel or SPSS to capture data. I'm just going to, let me just load another, I'm going to load that, is it? I just want to find, so I'm just going to find another thing for you quickly. Just need to find the project. What's the guy's name? It's not that one. So just bear with me for a second. I'm just trying to find a data set now. Sorry, I'm just going to load another file quickly. Wrong directory. Okay, I'm back here. going to just go share. What is going on here? Just go here, share. Excel. Okay, I'm just I'm just going back to this Excel file just to demonstrate a point. So this is data from health sciences. So it's a very different kind of data set to the data from a questionnaire. It's much more, these are sort of what we would call manifest variables. So we're measuring age, height, weight, and so on. Hip flexion, and so these are all kind of like scientific measurements that have been measured. Just to show you an example of a different kind of data set, which is not from a questionnaire. This would be from patient records, for example, from measuring patients. So when you measure data, when we capture data, sorry, the format that we use for analyzing the data, which is where we have the variable in the column and the case in the row, is very it's not really appropriate. It's not really aligned for good capturing and easy capturing, because you have to capture when you're capturing going across. I'm just going to go down to I don't want to add anything to this file, but so because this is the data set that I'm going to be using. So, but if you're trying to capture going across like this, it's much more difficult to go across than it is to go down when you're capturing. And usually, so the record, the patient record wouldn't have the data in this format where it's going across the page. It would be going down the page. So you'd have age first, and then you'd have height, and then the next line will be weight, and so on. So the format that we use for analysis doesn't align well with the format that we use for data capturing. So we can use Excel to capture data, and the student has done that, but it's not the most convenient or the most, if you've got a lot of records to capture, programs like Excel and SPSS are not the most ideal to use for data capturing. So we use other programs like Epidata, which unfortunately I can't show you, but Epidata has a page which let me just try something else. Sorry, let me just see if I can do this. So sorry, just also to make, before I'll use this file, just to also make the point that when I mentioned about the data being in the right format for importing, this data set is problematic because the student has put in these averages and minimum maximum here, and then they've also got these headings repeated again. So if we were importing this data into a program for analysis, it would read these columns, and then they would be, it's not the data that you want in the column. So before I import this data, I'll delete this information here, and I'll add a variable in, which will tell me that this is the group one. I'd add a grouping variable here. I'd add in a new variable here, and this is going to be the group, and then this is going to be group number one, and I'll mark all these as group number one. And then I'm just going to go down here quickly, Control V, and then these will all be group number two. Okay, so this will be group number two, and I'll know what the groups are from the code book, because the student will have provided a code book, hopefully telling me what the groups are. And then I would delete all this information here. I'm not going to save this file because this is my original data file. So I would delete that information there. This should be group one. And then I would delete this information here. And then I would, so we've now just got the raw data. I'd also have to sort out these headings here, because we can't have two rows as headings. We just want one row as a heading. So this will be group, this will be case number, age, height, and weight. And then these ones, I would combine these two labels into a single label, and then I would import the data in that way. So that's how we would sort of set up the file. So we'd have to make some edits to the file, and then once we've got that, we should have pretty good data importing. Okay, so I'm just going to try. So the point that I'm making, though, is that the structure of or the format that we use for Excel and SPSS is not good for data capturing. So I just want to try and share this maybe another way. If I do the screen, let me just put this onto the screen. I don't think that's going to work either, actually. Screen. Let's just see. I don't know if this is going to work. Can you see? Yeah, you can see it now. Okay, so that has worked. Okay, so this is a form in this is a program called Epidata. So what we do is we create a form that we can use. So this would be a questionnaire that we've developed. This is the structure of the questionnaire. So it's question A2, A3, A4, and then you just capture going down basically. So this will be case number 1. This will be hospital number 1. This will be the first type of ward. The person might have said no here, so we type in 2. The person might have said yes here, so we type in 1. This is open-ended. And so on. So this structure follows much more the structure that the questionnaire would follow. So we use for efficient data capture and for ease of use, we use a program like Epidata. And this is freeware, so it's free to use. You just have to learn how to use it, and it's not that difficult to use it actually. So what we do is we offer a service where we will create the file for the student. And then we'll capture the data for them if they don't want to do it themselves. My other colleagues, what they do is they will give the student a data capture shell in Excel or SPSS. But it is much more difficult to capture in that format. So this is much more, it's much easier to use this kind of format. So if the student's going to be doing a lot of data capturing, I would suggest sort of thinking about using something like Epidata rather than using something like Excel or SPSS. Okay, so that's so we use different. I think the overall point is we use different kind of software and different processes depending on how much data there is and what the data format looks like and so on. So that's this is Epidata. You have to create this form in another. Epidata has a few different components. There's an entry client, there's a program manager. So you create the form in the program manager, and then you enter the data in the entry client. And then they've also got an analysis option and stuff as well. So which we don't really use that because we've got more sophisticated tools that we use for the analysis. Okay, so I'm going to stop sharing that. And I think I'm now almost at the end of this component. So let me just see. Yeah. Okay, so I'm going to okay, so we're going to have a short break now. Okay, so let's just, so I've finished data capturing. Are there any questions before I continue? So we're going to have, and then we can, any questions, then we can have a short break and then I'll carry on with data analysis. Any questions? Okay, all good so far, right. Okay, so let's take let's just have a 5-minute break for now. Is that all right? So it's 9:47. Let's make it 9. Let's meet again at 9:50. I'll start again at 9:55. Is that all right? Okay, so 9:55 we'll start again. Right, I'm back again. All right, so we go just to quickly summarize with the data capture. It's important to have your data in the correct structure before you import it into a program for the analysis, and it's important to make sure that the data has been captured accurately. So you need that structure and the accuracy, because if you don't have the structure, you might have a problem uh, performing the analysis. And then if you don't have the accuracy, there's going to be questions about the validity of the findings. All right, so now we're going to move on to the analysis component, which is where things get more complicated because there's lots of kind of analysis that we can do. And I'm just going to, I've got a lot of slides in this presentation, but I'm obviously not going to get through all of it today. I just want to focus on a few key issues. And then we can sort of, when we get, as I say, when we get to the end, we can sort of have a discussion about anything else that you might want to know about. Okay, so I'm just going to move this forward. Sorry, I just need to get back here. What's going on here? I'm having a technologically challenged morning. Okay, there we go. All right, so this is here we're going to be focusing on data analysis or statistical analysis. So we're moving down to the final stages of the, whoops, sorry, I'm now going mad. The final stages of the kind of research process where the student is getting towards analyzing, interpreting the data, and then reporting their results, either in the form of a dissertation or in the form of a research paper, for example. So statistics is some definitions. Statistics is the science of collecting, summarizing, presenting, and interpreting data, and of using them to estimate the magnitude of association and test hypotheses. That's a quote from a book, Medical Statistics by Kirkwood and Stern. There is a new edition of that. I've got the hard copy of the 2003 edition, but there's a much more recent edition of that book. It's one of those books that it's a very renowned book, and it's constantly being republished. And then data analysis, a definition of data analysis is the art of examining, summarizing, and drawing conclusions from data. Good data analysis involves a mixture of common sense, technical expertise, and curiosity. So I've used those two quotes deliberately because you'll see that the one has the word science of collecting, and then the other one has the art of examining. So it's kind of juxtapositioning that analysis is both a science and an art. So although it's a very structured process that we follow, and there's lots of sort of scientific theory underlying the analysis that we do, there's also an art to doing an analysis as well. It's not just so it can be a very creative process, even though there's lots of structure and lots of scientific thinking behind it. Okay, so I'm just going to skip this. Okay, so yeah, this is just the main themes. I'm not going to go into detail about all of that. Right, okay. So in the last session, I introduced this diagram of with statistical tests. So when the student designs their research, they should have an analysis plan. Some of the examples, I've just got two examples of analysis plans from proposals that have come through to StatCon. So the first one, the student says, the data will then be allocated and divided into specific fields of interest. An Excel spreadsheet will then be designed with the help of StatCon to collect and analyze all relevant fields of interest. So you can see from that paragraph that the student doesn't have any idea about what the analysis is going to be. The second one, all data collected from respondents will be analyzed with the most reliable statistical analysis tools, so on, so on, so on. But nothing, there's no indication in that paragraph about, there's some mention later on about pie charts and histograms, but there's nothing about what statistics are actually going to be used. And as a supervisor, that's you're dealing with somebody who might not know anything about statistics at all. sorry, just to say that not all proposals look like this either, but it's the dilemma that the supervisor has is that the student might not know anything about statistics. When I was a student, I worked in disciplines which where statistics was kind of common. So when I was doing my undergrad degree, I did psychology, and psychologists do a lot of statistics. So I did a statistics course in second year, for example. I did biology, and biology, we had a statistics course in honors, for example. So during the course of my academic career, I was always exposed to statistics in various forms during the courses that I was doing, or the subjects that I was doing. But some subjects don't have that. So, for example, if you do chiropractic at UJ, for example, they don't have a statistics course. If you do humanities at UJ, they don't have a statistics course. So, but the student might want to do statistics for their project, and then the question is, how do they know what statistics to use when they're developing their proposals? Okay, so let's just get that sorted out. Okay, and then so that chapter that I sent you by Blakey, it's not the reason I think I've mentioned before. The reason why I use that chapter is because it's got a very nice it includes all the components that you need in a proposal, and it links the analysis to the research question. It's a nice example of showing how the student would say, this is what analysis I'm going to do to answer the research question. And I'll send you an email just to highlight that reading, because I think it's a very good sort of structure to it. So, and it's the analysis itself is not complicated that they're doing in the example that he uses. It's not a particularly complex analysis, but the key thing about it is it's kind of explaining what they're going to do and how they're going to do it. So it's a nice example to use for students to say, this is the kind of level of detail that you need to be showing. So if you look at this, these two examples here, where there's no kind of statistics at all, and then this example where it's explaining that cross-tabulation and non-parametric tests for significance will be used. So it's kind of explaining what tests will be used, not just sort of a vague reference to some kind of statistical analysis. And this is another example from that Blakey chapter. Yeah. So that's let's just make a note to do that. So it's Blakey email. So I'll just send you a bit of an explanation for why I like that chapter as a good example for students. Okay, and then that should also be a little bit of a hint for you for if you want to, something that you might be able to use for assignment 3. Okay, so a good analysis plan would include a reference to the research questions, so how they will be answered. So what I think most researchers, actually, not just students, they'll have their research questions, but then they won't link those research questions to once they've kind of mentioned them, they then disappear completely and you don't see them again. And then, so unless they're writing a research paper or a thesis, but in the proposal, there's no reason why you can't go back to them again and say, I'm going to answer a research question using this analysis, which is what Blakey does in that example. Okay, in the analysis plan, there must also obviously be reference to constructs in relation to their form of measurement and how they will be related to each other. So, for example, in these two student examples here, there's no variables there at all. There's a vague reference to specific fields of interest, and then the second student doesn't really mention anything about the variables that are going to be measured. And it's not just students that do this either. I sit on an ethics committee, and some of the staff members are equally guilty of it. So in terms of not sort of explaining what they're going to be analyzing in their analysis section. Okay, and then the third point is that the tests need to be mentioned. So what tests are going to be used and how they're going to be, and are they relevant for the constructs that are going to be measured? Is there going to be a hypothesis tested, for example? So again, in these two examples here, there's no tests mentioned here at all. It's just very vague. Okay. Yeah. So how does a student work out what analysis they should include in the analysis plan, or what analysis they're going to be doing? They can look at analysis which has been used in existing research publications. So often what we do is when we meet with a student, we'll sometimes say to them, please give us a research paper which is similar to what you're trying to do for your study. And that for two reasons. One is to kind of see to try and give us a better idea of what the student is doing, but also to try and understand what kind of statistics might be possible, because there's a huge range of options available. The student can also refer to resources which guide us on what statistics to use. So, for example, I'll show you we'll look at the field decision table in more detail now. And then there's also there's textbooks, for example, Pallant's book on the SPSS Survival Guide, which has a chapter on how to choose statistical tests, basically. The student can also get advice from experts such as the supervisor or the statistical consultation service. So often students will come to us for consultations, and then we will kind of explain to them what kind of statistics they can use. And then they can also attend statistical analysis workshops. Okay, one of the challenges with workshops is that because there's so many procedures and so many things that the student there's so many statistical procedures available. Most of them won't be relevant for the student's work, so they'll only be using a limited number of tests. They might only be using one test, for example. So you don't want to end up going to lots of workshops when they're covering procedures which are not relevant to the student, for example. So that's always a bit of a dilemma for tests. There might be workshops available, but they might not be covering the right kind of analysis that the student needs. Okay, so just in terms of sets of statistics, this will frighten you off if you're showing an interest in statistics. There's there's lots of different types of statistics. I've just used a very kind of simplified sort of classification. So we have descriptive statistics, and we'll look at some of those a bit later. We've got measurement of normal distribution. That's something that we do, which we need to do if we want to use parametric tests. There's statistics for reliability and validity, and we've covered some of those in a previous contact session. There's data reduction techniques, which is something like factor analysis, for example. There's inferential statistics, and there's many, many inferential statistic procedures. And then there's also effect size statistics, which we use to measure the effect of a significant result. So this is a very kind of simplified sort of categorization of or classification of procedures, but there are many available. But that shouldn't sort of put you off thinking about doing quantitative research or having your students do quantitative research. It's not you're likely to just use a few of the techniques available, and it's just so you don't have to it shouldn't be, that looks intimidating. It doesn't need to be. And then this is a list of many of the procedures that we can use. I'm not going to go into detail about each of these. The point of the slide is just to give you an indication that there's a wide range of different kinds of tests we can use under different circumstances. But depending on what kind of field you're working in, you won't be doing you certainly won't be doing all of these procedures. You might be doing 2 or 3 of them at most. Okay, and this is just more kinds of procedures. So I'm sure you've probably heard of correlation and regression and logistic regression or linear regression. You might have heard the terms inter-rater reliability analysis. You might have heard of MANOVA, multiple regression analysis, structural equation modeling. These are all sort of statistical procedures that you might have heard about at some stage during your career. All right, so let's start with descriptive statistics. That's the most basic, and we always, when you're doing an analysis, we always start with descriptive statistics anyway. That's the most basic level of analysis. And then there's different forms of descriptive statistics. We use descriptive statistics to describe measures and sample characteristics. So we have measures of frequency, which is a count and a percentage, and a frequency. Frequency is similar to count, so it's the same kind of thing. Measures of central tendency would be mean, median, and mode. I'm sure you've heard of those. And measures of dispersion or variation are things like range, variance, and standard deviation. And then we can also measure position, and that would be percentile ranks and quartile ranks, for example. So that's where we group people or objects into percentage into groups based on. So we might so if you're doing research on poverty, for example, we will talk about households being below a certain percentage of households being below the poverty level. So you might say this 20% of the households are at this level of income or expenditure. And we use the percentile ranks or the quartile ranks or deciles to group households into different levels of wealth, for example. Okay, then so the important thing so this is just a sort of diagram showing the normal distribution, which is sort of built from what we count and the percentages we get from the data that we have, and then so the normal distribution when we've got a distribution of data points, we can measure things like mean, median, and mode, and then we can also measure the dispersion, which is the standard deviation. So the central tendency, so the middle line of this diagram would be the sort of the line going through the peak in the middle that would be the sort of mean of the distribution, and then the dispersion is how much variation there is around that mean. So that's a measure of the extent to which the data points are spread out from the mean. When you have a normal distribution, it gives you a nice sort of curve shape like this image here. And we can use that when we have that kind of distribution, we can estimate very well how many cases are distributed within 1 standard deviation, 2 standard deviations, 3 standard deviations from the mean when we have this kind of perfect normal shape. So we use that when we have that shape, we can use that to do estimations quite accurately. When we have a skewed distribution, it's more difficult to do that. So the normal distribution plays a role in the statistical theory, and it's one of the assumptions of using parametric tests. Because when we have a normal distribution, we can make estimates of where values might lie. Okay, so the 3 measures of central tendency, which is the sort of tendency of the data to cluster around a middle value or a mid value, are the mode. The mode is the value that occurs most frequently. So if you've asked somebody how frequently do you do something, you give them the options never, really, sometimes, often, always, and they never might be the most frequent of those 5 values that you've given the participants to choose from. So it's just the most frequently occurring data response option. And you can get multiple modes. So a multiple mode would be where you've got this different answers or different numbers having the same number of people choosing that. So you might have the same number of people saying never and seldom, in which case you'd have a multiple mode situation in that scenario. The median is the middle value, so that's where you rank all your values that you've collected in ascending order, and then it's the point at which half the values fall above that middle value and half the values fall below the middle value. So that's the middle point. It's the 50th percentile of the data range. And then the mean is the numeric average. So that's where we sum the data. So if we've got values, let's say we've asked people how many hours of sleep they get a night, we'll take those values and add them up, and then we divide by the number of cases to get the average. So that's the numerical mean. And then we can also do trim means where we exclude extreme values that influence the mean. So when you're measuring something like income, for example, there's some people earning if you take an income distribution in a normal population, it'll be skewed towards the positive side because most people will be earning a lower kind of income, and then you get some people in the population earning these very inflated incomes, massive incomes, sort of Elon Musk income, for example. He would be an extreme outlier in terms of income. So if you feel like that value is a sort of inflated value and creating a problem with the distribution, you can trim the mean by removing that value. So then you get a more realistic picture of what most of the population would experience. Okay, the standard deviation is used to describe the dispersion. So we calculate the standard deviation by we calculate the mean, and then we subtract each data point from that mean, and that will give us the difference between each data point and the mean. Then we square the difference, and then that gives us a standard deviation value. The higher the value, the more variation there is in the data. So that's what we use the standard deviation for, is to estimate how much variation there is in the answers that people have given us. So yeah, so that's just that's a measure of dispersion. And then just to say, so in terms of sample size, if the data are from a sample, the standard deviation has a different definition than when it's from the population. But if the sample is larger than 30, so we have different definitions of the standard deviation, or different formulas, depending on whether it's from a sample or whether it's from a population. But if the sample size is larger than 30, there's not much difference in those calculations. So that's one of the reasons why in quantitative research, we would say that a sample size of more than 30 is desirable because of that. It gives us a better representation of the population. So we won't have a problem with bias because the sample size is small and our standard deviation isn't as close to the population as it could be. So that's why we always look for bigger sample sizes in quantitative research. These are just some formulas. I'm not going to go into detail about them, but obviously we need to use formulas to calculate this data. So just as an example, the formula for the mean is the sum of the values divided by the number of cases in the sample. So we just sum up the responses that the participants have given us, or we sum up the values that we've measured from a patient, for example, and we divide by the number of cases. That will give us the mean. Okay, and then yeah, I think I've covered this a little bit. There's also yeah, so we also use when we have ordinal data. We don't use the median. Sorry, we sometimes use we don't use the mean and the standard deviation. We would sometimes use the median and the interquartile range because those are more appropriate measurements for that type of variable. So the interquartile range is it's based on percentages. So we work with 25%, 50%, 75%. And then that gives us a measure of dispersion. We calculate the range between the 75th percentile and the 25th percentile, and that gives us a measure of the dispersion for a median-based distribution. So if we're using the median as the measure of central tendency, it's better to use the interquartile range as the measure of dispersion for that measure of central tendency. So we wouldn't normally use the mean and the interquartile range. We'd use the mean and the standard deviation, or the median and the interquartile range for data which doesn't where the mean wouldn't be appropriate. Okay, Not all descriptive statistics are used for all types of measures. So, for example, we don't sort of talk about an average gender or an average marital status or an average. I suppose you could have an average education level, because there is a sort of kind of numbering there, number of years of education. If you had a number of years of education, you could calculate an average there. But any kind of categorical or nominal variable, where there isn't a scale or a number involved or a numeric sort of interval variable, you wouldn't use a mean for that variable. But there's always exceptions to these rules. So if you had a nominal variable, we're more likely to refer to the mode for that variable than the mean or the standard, or the mean or the median. Okay, so I'm going to shift to I'm going to do a demonstration quickly. I just need to check that I'm using the right data set. Academic performance. So we run statistics in a program called SPSS. Now, if I can get this to load. So where's SPSS? Okay, so hopefully you can see this. Yeah, good. Okay. So this is a program called SPSS, which we use for statistical analysis. There are other programs that we can use. I'll come back to, So when you can run stats in Excel, for example, Excel it's a spreadsheet application which can be used for running statistics. And I've actually got a book on running statistics using Excel. But it's not actually designed for that. That's not its main purpose. Its main purpose is for more counting related, spreadsheet related functions. So calculating, or inputting numbers and so on, inputting financial data and then doing calculations on that kind of information. It's not specifically designed for statistical analysis, whereas there are programs like SPSS which are designed for statistical analysis specifically. So they're much more powerful in terms of the range of statistical procedures that you can run. So Excel can do some statistical analysis, but it gets, when you get to the things like factor analysis and more advanced regressions, general linear models and so on, it can't do those. So it doesn't have that capacity. So we use programs like SPSS. The main programs we use at UJ, for example, would be SPSS. Stata is commonly used by the economists, for example. And then you could also use something like R, which is a freeware program. But R has got a very high learning curve. You have to program R, which is quite so you have to be able to. And R it's not that easy to use it. So SPSS is relatively easy to use because it's got menus and so on. So there are many different statistical programs. And then UJ has a site license for SPSS, for example. It has a site license for Stata. So those are the two main programs. Most universities will have a site license for one or two stats applications. But there are many programs which are possible to use. And then some of them are open source, like R, for example. So you don't have to pay to use R. Okay, the license, whereas something like SPSS it's licensed, and to buy an individual license for SPSS is very expensive. So this is the program. It works like any other program. So it's got menus at the top here. There's two views here. There's an overview, which I never use it. And then there's a variable view, a data view, and a variable view. I'll explain those in a minute. There's a file function, so this is where we open and do things with files. There's an edit function, which I don't ever really use as much. There's a view function where we can control how things appear. There's a data function. Sorry, there's also, where's the options? Yeah, the one option under the menu, under the edit menu, which I would use as the options menu. And then sometimes one might insert a variable or something like that. There's the view variable where we can toggle between value labels. I'll show you that function when we've got a data set open. The data function is quite important. So this is where we can do things like sort cases and where we can select cases. So those are some of the functions that we would use here if you're using the menus. And transform is also an important menu. This is where we can create new variables. We can compute a variable here, or we can recode a variable here. Recoding refers to changing the label construction of a variable. Then we've got this is the most important menu in SPSS. This is the analyze menu. This is where we do all our statistical procedures. So you've got descriptive statistics. This is where we can run frequencies, descriptors, crosstabs. This is where we do a crosstab. There's compare means. This is where you'll find your t-tests and your ANOVA. Just go back here and one-way ANOVA. Here you've got your correlate menu where we'll run correlations, the regression menu where we've got regression models. But just to note that there's many different options that we can choose from here. So you're not likely to, normally when I run a regression, I'm normally doing a linear regression or a binary logistic regression. I'm not often doing other kinds of regressions. So those are the two most common, I would say, that we do, and sometimes maybe a multinomial logistic. Dimension reduction is classifiers where dimension reduction is where you'll find your factor analysis. SPSS only does exploratory factor analysis. It doesn't run confirmatory factor analysis. And SPSS also doesn't do structural equation modeling. So you have to use another program we use other software to do that analysis. And then scale would be your reliability analysis, for example. This is where we do the Cronbach alpha. So yeah, so non-parametric tests are also important. These are tests that we use when we can't use the parametric tests. So most of these tests here are parametric tests, but there is a non-parametric test menu if you can't. So for when you can't use the parametric tests, we use the non-parametric tests. Okay, so yeah, and then sometimes you might have a multiple response question where you need to run it as a multiple response, and that's where you define those variables here. So this is the menu that we use the most often because that's where we do the analysis basically. And then you can also draw graphs in SPSS. I tend to draw my graphs in Excel when I do them. There's nothing wrong with SPSS graphs, but I just like the Excel graphs better. So what I would normally do is export the information that I need and then create the graph in Excel. There's utilities. I don't often use this menu. I'm not sure if I've ever really used this menu. It's not something that I would use. And then extensions also not much. Window, we don't really do much. And then the help menu just gives you the help and so on. Okay, so I'm just going to open a data file. I seem to find it here. These are all my projects. I'm going to open this one. I think this is the right one I want to open for this exercise. Okay, and I can't do it now. Okay, so you should see, let me check that you're seeing the file. I can't see what you're seeing now. I'm just going to close this down. Okay, so can you see a data file in front of you with case maths before enter and academic performance?
No, there's nothing showing.
Oh dear, here we go again. Okay, let me just go to the screen. I'm going to have to do this using the screen, I think, then. I don't know, probably because I haven't shared it yet. Okay, let's try again. Okay. Okay, you should be able to see it now. Okay.
Yes.
Yeah, okay. I don't think I could. Yeah, sorry, I don't think I can blow this up at all. I can't increase the size. You might be able to increase it on your side. So this is a data set. So under data view, which is the tab at the bottom here, that shows the data. So you see it says case maths, physics before. That's just whether the person's done maths or physics. This data set is showing academic performance is the outcome variable. It's just rated from poor to excellent using a score. Then you've got, did the person enter from grade 10 or grade 11 or 12? So did they come into the program from grade 10 or from grade 11 or 12? So grade 10 would be a lower entry level. And then did they do maths or physics before they joined the program? Yes or no? So it's a very simple data set. These are the cases here. You must always number your cases in a data set. You must always, each case should always have a number. It's just so that if you need to identify a case which looks like it's got a problem data point or something, you can then find that case in the data set. If you don't have a number, then you can't find the case. So I was working with a supervisor with some student data just this week, actually. And they hadn't numbered the cases. So if you have to sort the data set to find something and then you need to unsort it again, you can't unsort it if you don't have a case number. So it's always important to have this case number in your data file. Okay, then, all right, so the data view shows you the data. You'll notice that it says no and yes here, but and I said when I was showing you the Excel sheet, I said we don't work with these labels. We want to work with numbers. The reason why it's showing no here is because if I go to view and take off the value labels, if I check off the value labels, the number actually shows here. This is what the data is actually made up of, noughts and ones and 4s and 2s and 12s. It doesn't say no or yes, it says 0, 1. But we've added labels onto the data so that we can, if you want to, see what the response is. You can see the no, but the data underlying this is actually a number. It's very difficult to work with alphanumeric variables when you're trying to do analysis. Okay. Okay, and then when we go to the variable view, this shows you the characteristics of the variable. So you can see we've got maths, physics before. It's a numeric variable. It's a dummy variable of did you, I'll extend the app, did you learn pure maths and or physical sciences in secondary school? The value labels are 0 is no and 1 is yes. So we've labeled those, and then that's just telling you that it's a nominal variable, for example. I'm just going to change this format to a scale variable. It doesn't really make any difference, but this is actually a score, it's not actually a nominal variable. I want it to be treated as a scale variable. Okay, so this is just a very simple file with 3 variables in it. So let's do some analysis on this file. So let's just see how many cases we've got. We've got 139 cases here. It's also important to keep check of how many cases you're working with when you're doing your analysis. Because if you might put a filter on accident and then accidentally forget to take it off, and then you end up working with a subsample instead of with a whole sample. So always monitor your number of cases when you're doing analysis. Okay, so this is why it's worth putting your data into a program and running it in a program. So it takes a bit of effort to get the data into this structure and into this program, but once you've got it in, you'll see how easy it is to do the analysis. So I put it in here, I've got the data and everything is like it should be. Then I go to analyze. I'm just going to run some descriptive statistics of the variables just to show you how easy it is. So I'm going to go to frequencies. Remember, we've got 160 odd cases in our data set. I'm just going to put all the variables in. We normally need to be a bit more, I'd normally be a bit more careful about what I'm doing with each variable, but because I'm just doing a demonstration, I just want to show you what it looks like. I'm going to click on statistics here. So I put the variables into the thing. So can you see a window saying frequencies and with a case and so on? I think you can, yeah. Okay. So I'm going to choose, if I click on statistics, I put the variables I want to run frequencies of in the variables box. And then if I click on statistics, I can choose all sorts of statistics here. So remember, I mentioned central tendency, so we can do mean, median, mode. I'm going to do all of these, even though we don't need them for 2 of the variables. Okay, so there's 2 variables which are nominal variables, but I'm just going to run the information anyway because I've got a 3rd variable where I want the median, for example. Okay, I'm also going to run a couple of statistics under dispersion. So I'm going to do the standard deviation, the minimum, maximum, although I don't need those for all the variables either. You can also measure skewness and kurtosis here. I'm not going to include those because I'm not interested in them at the moment. But you can, and then you can also measure percentiles here as well. So if I wanted to use, if I wanted quintiles, I could use 5 percentiles. If I wanted deciles, I could use 10 points here. I think this is wanting me to do percentages actually, which I'm not going to do here. So let me take that out. Quartiles would be 4 cutoff points. You could do cutoff points for, this would be deciles, 10 equal groups. If you did 5 equal groups, it would be quartiles. Okay, this is where you want, if you want more nuanced percentiles, you could use that option there. I don't often use that. So, okay, so I'm just going to choose those ones. I'm not going to use any percentile values. Click continue, click OK. And then we should get an output file, which I think you can't see. So let me just, because it's a different screen, so I'm going to stop sharing and I'm going to go back to share and share this screen. Okay, so you should now see an output file. Okay, so SPSS generates the output file as a separate file, which you can then save and export. So it's not part of the data file, it's part of the output. So you'll see, just going to the tables first, this is the frequency table for the question, did you learn pure maths and or physical sciences in secondary school? So I can see here that 44 people said no, 95 said yes. That's 31.7% who said no, and that's 68.3% saying yes. So that's my percentages that I would use for that, to describe the answers to that particular question. So it's taken 139 responses and done a very quick, within seconds, literally less than a second. It's counted how many people said no, how many people said yes, and what the percentages for those are. So I've got my results for that question. The next question is, what grade had you completed when you entered the program? 29 people said grade 10, that's 20.9%, and 110 people said grade 11 or 12, that's 79.1%. So again, very quick processing of those results. So a student could do the calculation themselves. They could literally, they could do it in Excel. They could count how many people said yes, how many people said no, and then get a frequency for that. So that is possible to do that. But the problem with doing it that way as well is you can't, you wouldn't be able to look at the association between those two variables. You wouldn't be able to do any more analysis or you'd have to do a more complicated analysis, which would be much more time consuming to say, what is the relationship between learning pure maths and what grade the person came from, for example. Whereas once you've got the data into a data set like this, you can do all sorts of things with the data, comparing variables, correlating variables, and so on, in a much faster way than you would be able to do if you had it in a spreadsheet, for example. And we sometimes we get cases where a student has summarized the data themselves. So they've put their data into an Excel sheet, and then they count how many people say yes to this question, how many people say yes to that question. Which is fine, but then they want to do a more complex analysis, but they can't because they haven't got the data in a structure which would be, or in a program which would allow for that. So basically, what we then have to do, or what we've done, is we've then taken the data, imported it into a program like SPSS, and then that allows them to complete that more complex analysis. So if you're just doing descriptives, you could do it in something like Excel, but it's not really you're limited in what you can do, basically. Okay, so this is the academic performance variable. So the lowest value was 2, the highest value was 12. You can see the distribution is a bit more towards the high end, although there are a few people. There's not many people performing poorly, and there's quite a lot of people doing very well. So there's 54 people that got 12, which is which would be an excellent performance. So, and we wouldn't normally report this kind of table because it's got a lot of information in it. The summary statistics are in this table here. So we wouldn't worry about a mean or a standard deviation for the first two variables, but it would be relevant for the academic performance. So this academic performance variable here, the mean is 9.3, which if you think of the scores going from 0 to 12, that's quite a good average. 9 out of 12 is a good score. The minimum is 2, the maximum is 12. The variance is 7.8, which is quite a high variance for a range of 0 to 12. So that suggests that there's quite a lot of variation in the performance scores. Yeah, understand. Sorry, I'm looking at the variance. I should have looked at the standard deviation, which is 2.7. So that's not too bad. That's not that high actually. Yeah, looking at the wrong figure here. Yeah, so that's and then the median is 10. And the mode is 12. So the mode is the highest frequency. So the excellent is the highest frequency. When the mean, median, and mode are equal or very similar values, that's an indication that we have a normal distribution. But in this case, we've got a skewness towards the lower side. We've got a negative skewness. So if I measured skewness, we'd probably get a negative score here. Okay, so that's your frequency. That's running a descriptive analysis for the variables. We can also ask SPSS to draw a graph. So I'm just going to rerun the frequency here again, and there should be an option here to run a chart, which I forgot to click this. So you could do bar charts, you could do histograms. Okay, so the histogram wouldn't be appropriate for the two. I'm just going to change the information here. I'm going to take out that variable. I'm going to run the chart with a bar chart, because a bar chart or a pie chart is the most appropriate chart for a categorical variable. And I'm going to make it the percentages, not the frequency. So you can see we've got a lot of options here. Continue. And then I'm going to click OK for that. And then we should end up with some bar charts there. Okay, I wouldn't normally run a bar chart with two categories, so that's not something I would normally do actually. But that's an example of a bar. You can run a bar chart, but as I said, I would normally you can edit the graphs in SPSS. So, but I just prefer drawing graphs in Excel because I think they've got more flexibility over how you can edit and so on. So that's the kind of figure that you could draw for a categorical variable. And then for the other variable, I'm going to draw a histogram because that's the most appropriate for an interval variable. I'm going to show a normal curve on that chart. So I'm going to click OK, and we'll end up with a histogram here. So that's what the distribution looks like for the performance. So you can see it's not a good normal curve because there's lots of participants with an excellent score, and there's a tail towards the lower end of the scoring. So the skewness, this would be considered a negative skewness because the tail is pulling out on the left-hand side or the negative side. So this is not a good example of a normal distribution, which it could be a good thing or a bad thing. I know the faculties like to have normal distributions with marks, so they would be very unhappy with this result here. So yeah, so that's your descriptive stats. Some of the things you can do with descriptive stats with SPSS, and it's quite easy. It's not a difficult program to learn how to use. Sorry, I didn't mean to do that. I'm just going to go back to the data set here. Yeah, so it's not, where's this thing up here now? Yeah, it's not it's not a difficult program to use basically, because once you've got your data in the program, you just need to go to the menus and find the options that you want to use. So I'm just doing a very simple kind of descriptive analysis at the moment with frequencies. But that's kind of how you could run your that's how easy it would be for a student to run frequencies and so on. There's also other things we can do here, but I'm not going to, you can sort of format the table so that you've got ascending and descending counts and so on, which can be useful. I don't often do that because I want to see the result in the order that it appeared in the questionnaire. If you change the order around, things can get a bit confusing. And then you can also create custom tables as well. Okay, but I don't. So when I learned how to use SPSS, it was a very long time ago, and it was I learned how to use SPSS on a mainframe computer using, and I had to send programming instructions to the mainframe to run the analysis on the projects we were working on. So I've always kind of continued to use syntax. So I don't actually use syntax is a programming language that we use to program, to tell the program what to do. So I don't often use the menu options. You do see it. I just want to show, let's also check something here. Let me just check. I think it's here. Yeah, it will be here. I'm just going to rerun that analysis again, or if I lost it. No, it's still here. So let me just show you the screen quickly. Sorry, it's a bit awkward going from screen to screen here because it's a different window. So if you look at when SPSS creates the output here, there's a log here. And that log is the syntax that SPSS has used to create the output. So there's a frequency command here. And then there's the variables that I've asked for a frequency for, and then it's the list of the statistics that I've asked for. And it's always good to include this in the output because then you've got a sort of audit of what you've done to get the output. So that's the syntax. So I don't actually use the menus. I just use this. I just create the syntax like this, and then I run the analysis. It's the same thing as using the menus, but it's not. I can sometimes do things much faster by using syntax than you can do using the menus. So, for example, a colleague of mine needed to convert some variables in a file that a student had provided. And if he'd done it by the menus, there was about 15 variables that he needed to divide by 100 sort of thing to get to the right unit of analysis. And if he'd done it manually using the menus, it would have taken him a long time. But I did it using syntax, and it probably took about 10 minutes. So it's not, there's sometimes using the programming language can be much quicker than using the menus, depending on what you're doing. But it's something that I would only suggest if you're using SPSS a lot, then it's something that you might want to learn. If you're hardly ever using SPSS, then the menus are fine. Because I use SPSS on a daily basis for the projects that we're working on, I need to have more efficient ways of working. So I use syntax. Okay, so that's an example of the descriptives. Okay, and I think that's now. Let me just check something else here. Okay, I've just got a couple more points to make, and then we'll take another break. I just want to go back to the slides now. I'm terrified of accidentally leaving the meeting by clicking the wrong button here. Okay, so one thing as a supervisor, so once you've got the analysis, once you've got the result, you have to then interpret the result, and then the student then has to write it up. So as a supervisor, you've got to think about first of all, the interpretation. Usually descriptive stats are not that difficult to interpret, but then the student has to write it up as well. So how do we write up findings from the descriptive analysis? Okay, so we have, let me go back here. So this is an example of output from SPSS. This is a set of rating variables. So the person has been asked to rate different questions. So the questions are things like, what is the likelihood of you returning next year if you pass all your modules? What is the likelihood of you returning next year if you fail all your modules? This was a study done with one of the technicons. where the success rate with the students is quite low. So they were trying to understand why students were dropping out of modules, why they didn't carry on with the programs and so on. So these are just some questions trying to measure likelihood of the person carrying on. So there's two sets of tables here. There's the frequency table at the bottom, which is the second table is the frequency table. Whoops, sorry, I've gone too far here, where it shows how many people answered extremely likely, likely, neutral, unlikely, and extremely unlikely. And then there's the summary statistic table where the mean is presented in another table. So SPSS gives you the output in two separate tables. You might want to combine them into one table. So if you want to present these results. So normally you might do a bit of editing you could just use these tables. But normally you have to do a bit of editing before you can present the results in a thesis or in a report or in a paper, excuse me. So this is from a book by Morgan et al. Called, I think the book is called From Numbers to Words. It's a very good book for which helps explain to a student how they would convert their information into a format which can then be presented in a publication. So this is one of the resources that I will share with students to say once I've gone through the results with them, to say this is how you need to report the result. So this table here, it's got a similar format to these tables here, where we've got the categories with the percentages and the numbers, and then with the means and the standard deviations. But what they've done here is they're a bit naughty in this table. It's not a perfect example actually, because they've combined strongly agree and agree into one response. So that's 75%. They've got neutral, which is neither agree nor disagree, is 7%. And then they've combined disagree and strongly disagree into one group, which is 18%. So originally they would have had 5 categories: strongly agree, agree, neither agree nor disagree, and disagree, strongly disagree. But they've combined them into 3 groups, which is fine. But when you look at the mean, which is 3.8, it's the mean of the 5 categories, not the 3 categories. So the presentation here is good. So they've got the questions, overall emphasis on physical appearance, conflicts between roles of wife, mother, balancing family life and job, and so on. So those are the statements that the person would have had to answer to. They've got the number of cases, and then they've got the mean, the standard deviation, and the percentage. But the percentage is based on grouping the categories together, which is what I don't sort of think that's I don't think that was a good thing to do here. I wouldn't do that myself, but they've done it as part of the example. And what they've also done here, which is good, is they've sorted the mean from highest to lowest. So it shows you which statement has the most agreement and which statement has the least agreement. Or maybe it's, yeah, so yeah, that's something else which I'm not sure about here, where the greater an items mean, the greater its importance as a career barrier. So that's so this is, I'm not sure what so I would also have maybe put the scale the other way around here, to have disagree as the lowest and agree as the highest. You can do it either way, but when you're presenting results, so in terms of interpreting and describing the results, if you have a higher score, it should mean something more positive, and that's just my opinion, and it's based on experience, because I once was involved in a research project where we were looking at sort of learner attitudes towards gender and stuff, and we used the scale where the agree was a low score and the disagree was a high score. But the agree was had a positive meaning, and it was very difficult to write up and interpret the results when the agreement was the lowest score. It was very awkward. So I would always have the higher score meaning the more positive outcome, and the lowest score meaning the more negative outcome. And it's career barriers. So if it's an agree, if they disagree that it's a barrier, then it would be a positive thing. I think that's, yeah, I'm still trying to work out what this mean means in terms of the greater the mean, the greater its importance as a career barrier. So I think they've actually, they should have presented this the other way around, where the agree was a stronger barrier, but I see why they've done it, because this is a positive outcome and this is a negative outcome. But the means are very confusing, actually. But anyway, yeah, so that's, yeah, it's a strange kind of table, but it's nice. So the presentation is nice. The interpretation is a bit dodgy, in my opinion. Okay, so yeah. So just and then just the final point about this is that we don't normally use a mean to represent ordinal scales. So this is an ordinal scale here, and we don't normally take a mean for an ordinal scale. But it can be useful in this instance. I think it can be justified because we can use the mean to rate the items from highest to lowest. And that tells us that there's most agreement with overall, overemphasis on physical appearance and conflicts between role of wife, mother, and newscaster. And then this is dealing with career barriers, balancing family and life jobs. So if we were to look at this, we'd say, okay, well, the most difficult barrier is overemphasis on physical appearance, and the least problem barrier is having to relocate. So that gives you a sort of a rating of which is the most difficult barrier and which is the least difficult barrier for the women who are television news anchors. Okay, so this, if you're helping a student with reporting on descriptive analysis, a good option to use would be Morgan's book, Morgan et al. From Numbers to Words. It's a very good, and it has chapters on different statistical options. So it's got a chapter on descriptive stats, it's got a chapter on reliability, it's got a chapter on correlation, it's got a chapter on regression. So that it doesn't cover all the statistical tests, but it's a good resource to use for helping students. So again, thinking about assignment 3, if you're dealing with the write-up phase if you're thinking about how would you support a student for the write-up phase of their quantitative research, this is a good resource to use. This would be a good option to share with them to help them write up their results. Okay, so I'm giving you some hints here for assignment 3. All right. Okay, so we're going to have another break now, and then we're going to go on to the more complicated statistics, which are the inferential statistics. So we're going to, it's now, let's say 11. So shall we meet at 10 past 11? Is that all right?
Yes, Doc.
Sorry, before you go, are there any questions quickly? Or shall I ask you when we come back? Okay. Let me ask you if there's any questions when you come back. So 10 past 11. Okay. I'll see you again at 10 past 11. Thanks.
Thanks, Doc.
All right. Right, we're in the final stretch of a Saturday morning. All right, so I'm just going to, I'm not going to go into a lot of detail about the theory of statistics. I'm going to rather use some examples to show you what students could do in a simple way. So inferential statistics are used to test associations, correlations, and relationships between variables. So descriptive analysis doesn't give us any information about the relationship between variables. It just tells us what that variable looks like. It doesn't tell us what the relationship is between variables. And if we're going to test hypotheses, we need to, you can do single sample hypotheses or single variable hypotheses. So you might, for example, let's say, for example, you've measured, let me think about this, think of an example now. Let's say, for example, students in 2004 did a rating of their satisfaction with UJ. You could then get a sample for 2005 and test whether the rating in 2005 is equal to the rating in 2004. So that would be a sort of, it was a satisfaction variable. So you can do those single variable tests, but we don't often use those. We're usually more interested in the association between variables, correlation, and so on. And we also want to, so those are the kinds of things we want to do, and we need to use inferential statistics to do that. You can use descriptive statistics to compare variables as well, or to look at correlations and things, but normally we want to have some kind of test to give us, to kind of say with some level of certainty whether the correlation we're seeing or the association between variables is statistically significant or not. So you can do descriptive analysis of associations and correlations, but we normally want to have some kind of sort of evidence that there's a meaningful correlation or association there. So some examples of the parametric tests are independent samples t-test, one-way ANOVAs, paired samples t-test, repeated measures ANOVA, Pearson's correlation, and various types of regression. So those are the sort of normal kinds of tests that we would use for parametric tests. There are some assumptions for using parametric tests. I just want to spend a little bit of time going through those. One of the assumptions is that, and this applies to most parametric tests, and then the test will also have their own assumptions as well. So each test might have some of its own assumptions. So the first assumption is that the dependent variable must be measured as an interval or ratio level. So it should be a continuous scale rather than discrete categories. So that's one of the assumptions, but it's not actually. So if you do a logistic regression, for example, there are tests where you don't have to meet this assumption. So for example, if you do a logistic regression, the dependent variable is a categorical variable. So it's not, or also a multinomial logistic regression, the dependent variable is a categorical variable. With random sampling, so the second assumption is that they assume that the values or the scores or the data have been obtained using a random sample from the population, and that's quite difficult to, that's sometimes very difficult to achieve. So I think most samples probably aren't random. So sometimes we'll just not use this assumption too strictly. Okay, and then you will get statisticians who are very strict. Statisticians would say you shouldn't really be using parametric tests if you don't have a random sample from a population. The third assumption is that the observations must be independent. What that means is that if you've got cases in your data set, they must be independent of each other. They can't be related. So just to give you an example of that, I'm working on a PhD project at the moment, where the student has collected data for 2 years from a company. She's measured various indicators for those 2 years, but the same employees could be in the data set in both years. Some of the employees will be the same, some of them will be different. but because quite a few of the employees are the same, if you were to group those two data sets into one data set and to combine the 2004 and 2005 data sets, the cases wouldn't be independent because you've got the same person answering twice. So that's an example where the data wouldn't be independent. If the data is kept separately in the 2 years, that's fine, because then for each of those years, the data is independent. But if you combine them into one data set, it wouldn't be independent data. Okay, the fourth criteria or assumption is that the data has a normal distribution. So that, or the idea is that the populations from which the samples were drawn are normally distributed. Most tests are tolerant of this assumption, and with a large enough sample size, the violation of the assumption shouldn't cause too many problems. So although it's an important assumption, we can usually, if you've got a big enough sample, then you should, there's something called the central limit theorem, which we can use to indicate that this assumption shouldn't be a problem. And then many of the tests are robust enough to deal with the violations of the assumption. And then also they might have some of the tests have a variation which takes that assumption into account. So there are ways we can deal with that assumption. And then the final assumption is homogeneity of variance. And what that means is that when we're comparing groups, when we're doing comparisons between groups, for example, the indicator that we're measuring should have equal variance for those groups. What that means is that if we measure, say, a group of men and women for performance, their performance values should fall, the dispersion of their performance values should be similar. But a number of tests also have alternatives or have variations which take into account the equal variance. If there isn't equal variance, there's an alternative test which takes that into account. So, for example, the independent samples t-test has two versions of the t-value which take into account equal variance and not equal variance. So they can be tolerant of this violation of the assumption as well. Okay, and then I showed this diagram in the last thing. I just want to, I don't know if I can get this any bigger. I don't think I can zoom in. Let me try and zoom in here. Okay, so I'm just going to zoom into this. Let's try and do that. Okay, that does work. Okay, so this is okay, that's zoomed in. Now I've zoomed out again. Okay, so this is a table from Andy Field's book on using SPSS. And I just want to spend a little bit of time going through this. So on the right-hand side, you have tests. The red squares are statistical tests. So you've got a biserial independent t-test or a biserial correlation, the Mann-Whitney test, the dependent t-test, the Wilcoxon's matched paired test, the one-way independent ANOVA, the Krishkal-Wallace test, and so on. Oops, I've zoomed out accidentally. So that, no, it's not zooming in. Here we go. And then, so that's on the right-hand side. There's not all the tests are listed here, but there are a number of common tests that we use listed in this on the right-hand side here. As we go from the left to the right, we're asking questions here about the statistics. We're asking questions which are going to get us to a statistical test. So all these tests are inferential tests. So they're all looking at some kind of correlation or some kind of comparison between variables. The first question we ask is how many outcome variables do we have? And the options are one or more than, or two or more. So those are the options. So the first question is how many outcome or how many dependent variables do we have? And the answers there are one or two or more. The next question is what type of outcome is it? What kind of dependent variable is it? And the options there are continuous or categorical. And there isn't, you'll see there isn't an option for categorical for the two or more dependent variables. Usually you'd sort of anticipate that they would be continuous, but there will be options for that as well. It's just not in this table. So the continuous variable would be an interval variable, something like what is your income level? No, is this not working? So it would be what is your income level as a raw income per month. That would be an example of a continuous variable. Or what percentage did you obtain in a test? That would be an example of a continuous variable. Categorical variable would be something like what is your marital status? And also we group ordinal variables into categorical variables for this kind of choice making here. So if you have a single question where you ask, please rate this, please rate the quality of service, and you would then say very poor to excellent. If there's just one question measuring that quality of service, we would treat that as being a categorical variable. But when we build latent variables, I think I mentioned the last session, we would treat the latent variable as being a continuous variable, not a categorical variable. Okay, the third question is how many predictor variables do we have? So that's how many independent variables do we have, and the options there are 1 or 2 or more. So that's the option for that question. And then the fourth question is what type of predictor variable is it? And the options again are categorical and continuous. So the same definitions would apply there. Oh, man. And then I'm going mad here. Let's go back. Okay, it's getting even worse. Back. Sorry, I'm having control problems here. Okay, so zoom in. Okay, then the next question is how many categorical predictors do you have? I'll come back to this. So that's basically how many groups do you have that you're comparing if you're comparing groups. And then the next question is if it's a categorical predictor, do we have the same participants or different participants in each group? And then the last question is, do the data meet the assumptions for parametric tests? Okay, so I'm going to come up, I'm going to use this pathway as an example to begin with, and then we look at another pathway. Okay, so the first question is how many outcome variables do we have? And we'll say we've got one outcome variable. Let's say that's performance. Okay, so we're going to say, how well did a group of students perform in an exam, for example? So that's a continuous variable. We're going to get a mark. So we'll from 0 to 100%. So we're going to that will be classified as a continuous outcome variable. The next question is how many predictor variables we have, and we're going to say 1. So I'm going to use the example of what let's say what's the year of study of the student. So is it first year or second year, for example? Okay, the next question is what type of predictor is it? If we're using first and second year, it's a categorical variable because the year of study is a categorical variable. If we just use 2, let's say we're just comparing first and second year, then we would have 2 categories in that categorical predictor variable. Then the next question, this question is more complicated. So if it's a categorical predictor, do we have the same participants or different participants in each category? If the students are in first year or second year, they're going to be different because we can't have a student who's going to be in both first year and second year. They'll be in one year or the other year. So the answer to that question would be different. So we're coming to this test here. And then the last question is, do the data meet the assumptions for parametric tests? And as I've just said, there's a number of assumptions that we need to meet. So let's say the students let's say the data doesn't meet the assumptions for a parametric test, then we would use the Mann-Whitney test. That would be the option that we use there. That's the non-parametric equivalent of the independent samples t-test. If we answered yes to this question, the data does meet the assumptions for parametric tests, then we would use the independent samples t-test, which is, so we've got 2 independent samples, first year and second year, and we want to compare the scores that the students obtained in their exam for those 2 years. So that would be that's the dependent variable. So we're comparing the average scores for each of those 2 groups. If we follow a slightly different example, so we've got one using the same pathway, one continuous outcome variable. We're going to have one predictor variable, but we've got 2 or more than 2 categories, sorry. So we've got, let's say we've got first years, second years, third years, fourth years, and yeah, let's say 4 different years of students. They're going to still be different in each group. If we meet the assumptions for the parametric tests, we would use a one-way ANOVA. If they don't meet the assumptions for the parametric test, we would use a Kruskal-Wallis test. So if we've got more than 2 groups that we're comparing for scores, for performance, we would use the one-way ANOVA for that analysis. So this is just kind of you're going to get to a different test depending on what kind of variables that you're working with. Let's do a different example where we've got one outcome variable, but it's a continuous outcome variable. But then our independent variables are going to be continuous variables. Okay, so that's just want to see where I don't want to get there. Sorry, I'm going to go up here first. Let's just use a more simple example to begin with. So we've got one outcome variable. It's a continuous variable. So we've got our mark, and then we've got one predictor variable, which is also going to be a continuous variable. So we're going to go to this option here. So what we're doing here is we want to look at, see if there's a correlation between the mark that the student obtains and the amount of time they've spent studying. So that's our independent variable would be how much time did the student spend studying. So that's going to be a continuous variable. And again here, if we meet this, then we don't have any groups here because we're not comparing groups. We're comparing. We want to correlate 2 variables together. So there's no group comparisons going on. So we've got a Pearson's regression here if we do meet the assumptions, that's the Pearson's correlation coefficient. And then if we don't meet the assumptions, then we'll use the Spearman's, it's Pearson's correlation coefficient, not the regression. You could do regression as well, but we'd normally just use the correlation. And if we say, no, we don't meet the assumptions for the parametric test, we would use a Spearman's correlation or a Kendall's tau statistic for that test. Okay, so those are sort of simple bivariate kind of analysis that we could do. We can also do more complex analysis. So if for example, we have one dependent variable and it's continuous, and we have 2 or more independent variables, and they are both continuous or categorical, then we would end up with a multiple regression or a ANCOVA analysis of covariance. So that's how we'd end up with a multiple regression. Also, if we just have continuous independent variables, which are 2 or more, then we would do a multiple regression. Okay. If we have a categorical outcome variable and we have 2 or more independent variables, which are both, and then we could end up with a logistic regression, for example. So that's how you end up choosing the test that you choose by, it's not always a sort of a concrete decision. There's always going to be sort of exceptions to the options that you're choosing. There's quite a lot of flexibility over what kinds of tests we can use. But this is how a student can learn sort of, or how they can sort of decide what kind of analysis they're doing. So by understanding what kinds of variables that they have, and what kinds of relationships they want to examine between those variables, that will help them decide what kind of test that they want to use, that they need to write up in their proposal, and then also what they're going to use for their analysis. Okay, so I'm just going to stop sharing this. Are there any questions about this table? Okay, so you're all good. Okay. All right, so I think, let me just check here, since we get out of here now and zoom out. Yeah, so just in terms of also supporting students, there's a very good book by Hancock and Muller called The Reviewer's Guide to Quantitative Methods in the Social Sciences. And just although it's, I think I've mentioned before, although the title says social sciences, all these tests that are here can be used in any discipline. It's not just social sciences. So there's no reason why a scientist won't use analysis of variance, for example, either a straightforward analysis of variance or a repeated measures design. They might not use a factor analysis. That's more likely to be used in the human sciences. But there's no reason why they wouldn't do correlation or regression analysis, for example, in science versus social science. So it's not really in survival analysis they will do in the sciences as well. So although it's kind of pitched towards the social sciences, it's appropriate to any discipline. And in this book, they have very good chapters on each of these methods to say, if a student was using it, what would they need to focus on? So it's the same book that I got the desiderata for the research design from. So again, this is a good resource to use for students. So if your student's going to be using correlation, there's a nice chapter on correlation which explains what kind of criteria the student needs to look out for when they're doing correlation analysis. And it's quite, this is a good resource to use if you've got students using any of the statistical methods. And this is just an example from different things. Yeah. So I'm just going to jump to an example now, because I think it's always better to, I'm not going to go through any more slides. I don't think I've got any. I think I just want to show you a demonstration using SPSS of how we do the analysis and how we interpret the results. And then I might come back to something. I don't know why this is displaying. It's not what I chose for the display. Sorry, it's just I'm talking to myself here. But I don't. I think the only other issue would be, other than giving a demonstration, is to say, how do you help a student then write up the results? What kind of resources do you use to help them with that? So I'm just going to go back to SPSS now. I've got a new file loaded. I'm just going to go here. Oh, have I not been sharing my slides?
Yeah, just for about 2 minutes, maybe.
Yes.
Yeah.
Okay, sorry. Okay. Gosh, okay, I'm sorry. Okay. Right, so this is a new file. Okay, so this is a file containing some variables which have salary, there's sex of the person earning the salary, there's how long the person's been working, the age of the person, their salary now, the education level. I'm not sure what the work variable is. It's the their work experience coded as a number. It's their job category. So there's a number of job categories: clerical, office trainee, security officer, college trainee, and so on. There's a ethnic group classification, which I'm not going to worry about, and then there's a sex race combination, which I'm not going to worry about for this demonstration. Okay, so if I were to ask you the question, what do you think the relationship would be between the salary of a worker and the sex of the worker? What would you anticipate about that relationship? What would you say? Do you think males and females will have equal salaries, or do you think there will be a difference in their salary?
Often there's a difference, but I think it shouldn't be like that. Yeah.
Okay, so we're not sort of commenting about the So it's not, so the exercise is not about sort of is it right or wrong, whatever the answer is. It's just about saying what evidence do we have? So it's to say, it's just to ask the question, is there a difference or not? And so based on what we know in society, we might anticipate that there would be a difference, but let's look at the data and see what the data tells us. That's why we do analysis. Okay, so this is just it's a data set. I think it's in one of the SPSS data sets they give you to. So in their books, they have examples in their help, they have examples. So this is one of the data sets from which they use to demonstrate certain procedures or certain points. So I'm just using that. Okay. So if we analyzing, I'm not going to go back to that table, but if we're analyzing, if we think about that relationship between sex and salary, what's our independent variable in that relationship? And what's our dependent variable and what's our independent variable if we're looking at sex and salary? Which one is the independent variable and which one is the dependent variable? Any suggestions, or should I just tell you? Okay, so let's go to, so we've got sex as a categorical variable, and I'm going to use salary now, the current salary as the dependent variable. So I've just told you, and that's a numeric variable. Okay, so if we just do a quick descriptive stats to see what the variables look like, we've got sex of employee and current salary. Whoops, I don't want to do that. Sex of salary and current salary. If we just look at the entire sample, just going to run that, and then you won't be able to see this. I need to toggle the screen. To stop sharing that window and share the new window. Okay, so now we've got our output. Okay, so in our sample, we've got 474 people. Just over half of them are male and just under half of them are female. And the current salaries range from 6,300 that's the lowest salary, to 54,000. So this might be a monthly salary for the person that the sample is earning based on the particular sample that they're using. Okay, so that's what the variables look like. So we want to sort of establish whether males and females have the same equal salary on average, or whether they have a different salary on average. So to do that, we need to use an independent samples t-test. This is our dependent variable as an interval variable or continuous variable. And we've got two groups in our dependent variable, and they are different. There's different people in each group. So that would lead us to the independent samples t-test. Okay, so I'm going to go to analyze. The compare means menu is where I find the independent samples t-test. That's the one that I want to use to compare these two groups for their salaries. Okay, so I go to independent samples t-test. I'll go to current salary is our test variable, our dependent variable, and then sex of employee is our grouping variable. It's asking me to define the groups, and I hope I'm going to get this right. I just want to check something quickly in the data set. Yeah, so naught is 0 and 1, so I just need to check that quickly. So this is going to be 0 and 1 for, so male is 0 and female is 1. Okay, so there's not much you can do with a t-test here. It's pretty straightforward in terms of what the result, what's going to be generated. So there's not a lot of you don't need to make many choices with the options that you're going to do. So I'm just going to click OK, and then we're going to get some output, which will tell us whether there's a significant difference between the males and females. So immediately looking at the means here, I can't change this view. I can't zoom in here. Maybe if I go here, I'm not going to fiddle around here in case I lose the screen. Okay, so if you look at the average for the males and females, the average for males is 16,574, and the average for females is 10,412. So just looking at the average, I can see that it seems like there is a difference. But the standard deviations are also quite varied. So the standard deviation for the male is much higher than the female, 7799 versus 3023. So that tells me that yes, the male salary is on average higher, but there's also more variation in the male salary. So that suggests that if there's an overlap between the variation, then there might not be a statistically significant difference. So we need to go to the statistical test. So in absolute terms, the average salary for males is higher, but we need to actually test that using a statistic. So we then go to this next table here, and this is where we get the information from the t-test. Remember, one of the assumptions for a parametric test is that we have equal variance for the two groups. And I can see from this result here that that's probably not likely to be the case, because the variation in the male group is much higher than the variation in the female group. So if I look at the Levine's test for equal variance, that's significant. So the test, this is a sort of a test that we look at before we use the t-test result. And this is telling me that the null hypothesis here would be that there's the variance for the female and male samples is equal. But I'm going to reject that null hypothesis because there's a significant result for the equal variance. So there is a difference in the variance between the males and the females. Then I go to the t-value, and you'll see for the t-value here, there's two options. There's an equal variance is assumed and an equal variance is not assumed. So based on this result here, I'm going to use the second option, which is the equal variance is not assumed. And basically, there's just two ways of calculating this t-value. One where we assume equal variance and one where we don't assume equal variance. And I'm going to use the second one, which is a more cautious analysis, because we don't have equal variance between the groups. When I look at the result for the t-value, the t-statistic is calculated by calculating the difference in the means between the males and the females. I'm not going to go into detail about the formula, but this t-value comes from calculating the difference between the mean of the male and the female and taking into account the sample size as well. So that's how the t-value is calculated, by looking at the difference between the means. If you get a low t-value, it means that there's probably not much difference between the means. But if you get a higher t-value, it means that there could be a difference. So this is quite a high, there's no right or wrong value for that t-statistic. But the bigger the value, the more likely there is to be a significant difference. Looking at this result here, I can see that there is a significant difference between the average salaries for males and females. So it's I'm using the two-sided p because I don't know if I knew that, if I was expecting that one group would be higher than the other or lower than the other, then I would use a one-sided p-value. But I can't state that hypothesis because I'm not sure what the result is going to be. So the null hypothesis here would be that the means are equal. We would reject that null hypothesis based on the result that we get for the t-statistic here, which is a low p-value, a p-value less than 0.05. Just to, when we do a test, we need to use a statistic. So when we do a statistical test, we start with the hypothesis, which will be that in this case, in this example, it will be that the means are equal. Okay, so then we test that hypothesis using the data that we have here. We calculate a t-statistic, which is in this case 11.688 if I use the correct one. The degrees of freedom is related to the sample size, so we normally report that, but it's that this number comes from the sample size. And I'm not going to go into detail about what it means, but it's related to the sample size. And then we get then we get a p-value, which in this case is 0.001. We compare that p-value to a cutoff value or a critical value, which we normally set at 0.05 for sort of social research. So if we're working in social research and in most scientific research, we would set the p-value at 0.05. Sorry, not the p-value. We call it an alpha value or a critical value. at 0.05. So if our p-value that we get for our test, which is this p-value here, is less than that 0.05, then we reject the null hypothesis. So a null hypothesis here is that the means are equal. We're getting a relatively high t-value, and we're getting a p-value which is less than our critical value of 0.05. So we'll reject the null hypothesis that those means are equal. So what we would conclude from this is that we have that the salaries of males and females is significantly different. And it's statistically significantly different. So it's not, we're not just saying that based on the averages that we see. We've also done a test to say the chance of getting values of 16,000 and 10,000 is not purely due to chance. It's due to the groups having different salaries. Another thing we can do is when we get a statistical result, we can also look at the effect size, which is in this table here. A common effect size we use is the Cohen's d, and this has got a high value here. We're getting a very high value for the Cohen's d. So it means that this difference that we're seeing has got a very large effect. It's a very meaningful difference. So based on this result, you would sort of conclude that there is a difference in salaries between males and females. And if you were doing that kind of research, you would be probably interested in having a more equal salary between males and females. And this would suggest that some kind of policy and intervention is needed to make the salaries more equal. So that would, that's the kind of direction that you would go in terms of, so you've identified that there is a difference in the salaries, and if the objective is to have more equal salaries, this evidence is suggesting that there is a difference, and it's a very meaningful difference, and therefore policy and action needs to be taken to address that difference. Okay, so that's how we'd use statistics. In terms of writing up these results, again, like with the results for the descriptive stats, there's a range of resources that we can use to share with students to help them. So, for example, the book by Palant, Survival Guide to SPSS. Palant's book has a number of chapters on various different statistical procedures. And then at the end of each chapter, she's got a little example of how to write up the result for that, based on what was discussed in that chapter. So that's a resource that students can use. So when we give students feedback, I normally, let's say, for example, I've discussed a t-test with them, I will normally then share with them the chapter from Palant, which deals with the t-test. So then, there's actually a number of different types of t-tests in the chapter, but I'll find the excerpt which talks about independent samples t-tests, and then I'll share that chapter with that excerpt with the student, so that they can then write up. It gives them guidelines on how to write up the results, because you don't want students sort of writing up on an ad hoc basis and sort of making nonsense, sort of or doing a poor write-up of the statistics. Okay. I'm just going to show one more test. Okay, I'm running out of time a bit here, so I'm just going to show one more test. So I'm going to do now a correlation. Can I do that here? Stop sharing. Okay, so let me ask you again here. I'm just going to go back to the screen. So I have to toggle between these screens because SPSS creates different screens. Okay, so what would you say, what would you expect the correlation to be between salary and education level? Do you think there would be a correlation, a positive correlation between education and salary level, or do you think there will be no correlation between those two variables?
There would be, I would say.
Yeah. Okay. So I think we would expect there to be, so education level would be measured by the number of years of education that the person has. So if you've done school, it might be 12 years, for example. If you've done through to postgrad, it would be sort of 18 years of education. So this education variable if you look at it's got 16 years, 18 years, 15 years. Some people have got 8 years of education, for example. So that's how that variable is constructed. So it's an interval variable. Somebody's got 21 years of education here. So that's somebody that's been studying for a long time. So let's look at the correlation between. So I think normally, I think it's a fairly well-established relationship that the more education a person has, the better the kind of job that they can get, and that would probably indicate the better salary that they might have. So let's just look at a correlation. We go to analyze and we go to correlate, and we're just going to do a bivariate correlation. So we're only going to look at two variables in an analysis. Okay, for the bivariate correlation, we just need to put the current salary and the education level. I'm just going to look at those two just to keep it simple. You'll see the options here under correlation coefficient. We've got Pearson's and Kendall's. Sorry, I don't want Kendall's, I want Spearman. So Pearson's is the parametric correlation. Spearman is the non-parametric correlation. I'm going to put both of those in just to show you what they look like. And then there's a couple of options. You can flag significant correlations, which I want to do. And then there's also an option to show only the lower triangle, which is if you've got a big table, that's sometimes when you do a correlation table, it shows a mirror image of the correlations, and that makes it look a bit simpler. Okay, so I'm just going to click OK. We don't need to do much else. And then I'm going to have to toggle the window again here. Stop sharing, and I'm going to share the new window. So here we've got our output. Okay, so this is the correlation table. I should have check that option off, but it's fine. So the correlation between current salary and education level. If in this relationship, the education level would be the independent variable and the current salary would be your dependent variable, because your education level might influence your salary, but your salary doesn't create your education level. So that's the way to think about it. There could be, you could argue that somebody with a higher salary might be able to advance their education more, but we're not looking at this in a longitudinal way. We're just looking at it as in a cross-sectional way. So your education level could potentially influence your salary level. Your salary level doesn't create your education level. That's the way I would look at that. If you look at the correlation coefficient can range from -1 to +1. And the closer to 1 it is, or the closer to -1 it is, the stronger the correlation. So you can see here we're getting a correlation coefficient of 0.688, which is what we would consider a strong correlation. There are ranges that we use, so a correlation coefficient of between 0.2 and 0.5 would be 0.3 and 0.5, sorry, would be considered a moderate correlation. A correlation less than 0.3 would be considered weak, and a correlation above 0.5 is considered strong. So this is a strong correlation between education level and salary, and it's significant. So we do a test on that. We conduct a test on that correlation coefficient to assess the significance of that test. And I can see from the p-value here that that is a significant correlation. So what the hypothesis here, the null hypothesis will be that there's no correlation between education level and current salary. But we're going to reject that null hypothesis because we've got a p-value of less than 0.05. And we've got a very strong correlation between those two variables. It's a positive correlation because the sign there's no negative sign in front of that correlation. So we know that so what that means is that the stronger the education level, the higher the salary the person is earning based on the sample that we have here. It's not a perfect correlation, but it's a strong correlation. So in general, the better the education level, the better the salary the person will be earning. Okay, so that would sort of confirm if we had other research saying that there's a positive relationship between education level and salary. Our data is confirming that what we know about that relationship. You could have data which contradicts it, but in this case, it's confirming that we tend to assume that there's a positive correlation between education level and salary, and this data is confirming that result. Yeah, so that's an example of a correlation analysis, just to show you that it's relatively easy to run it. And again, if the student was reporting on this, there would be resources that we could give the student to help them write up the results and how to present them and so on. Okay, so I think I'm going to stop there and just because yeah, there's lots of other kinds of just also to say this is the Spear. I'm showing you the wrong table here. I beg your pardon. This is I'm using the Spearman's correlation here, but I should have been showing you this one first. I beg your pardon about that. So this is the Pearson. I normally just run. This is the Pearson's correlation. This is the parametric correlation. And then this is the Spearman's correlation, which is the non-parametric correlation. The way that the difference between them, just very quickly, the Pearson's works on the raw data. So it takes the raw data and correlates the raw data. What the Spearman's does is it ranks the data, it converts the raw data into a ranking. So the person with the lowest salary will get a ranking of 1. The person with the next lowest salary will get a ranking in 2. The person with the highest salary will get a ranking of 474. Because that's the highest possible number you can get if you're ranking the data. And it will do the same for the education level. So the person with the lowest education level will get a ranking of 1. And the person with the highest education level would get a ranking of 474. And then it correlates those two ranking variables rather than the raw data. But you can see that there's very, very little difference between the correlation coefficients. And one of the reasons for that is the sample size is very big. So any kind of outliers would be won't be sort of having that sort of significant an effect on the data. And also just looking at the frequencies of the salary, there aren't any. There is a sort of a relatively high salary here, which is 54,000, but it's not. It's not a sort of massive outlier in terms of the next lowest value or the next highest value. Yeah, the value below it. There's not that much of a gap between 44,000 and 54,000. If there was a value here of like $1 million a month, then that would probably create a bit of an issue with the data. But this is not that far away from the next value. Yeah, so that's how a student would do the correlation analysis. And obviously we can do much more complex analysis than this. Okay, so I think again, so supporting a student would involve helping them navigate the statistical analysis they need to use. If they're trying to do the analysis themselves, it would involve helping them navigate the statistical software, and then how to interpret the output and how to write up the output. But there are good resources for those kinds of things. Yeah, so I'm going to stop there. I'm not sure if I've convinced you to do quantitative analysis. I hope it's not. But it's really not that difficult if you kind of practice it. But I would also say that if you're going to use statistical analysis or do quantitative research, it's a good idea to not just do it as a once-off and then never do it again, but to try and do it regularly, because then you're going to learn much more about it. Yeah. Okay, so I'm going to stop there. So I think 2 questions. One I would ask is, do you have any questions on the material covered? And then the other question is there anything else that you need to know about or that you'd like to know about where we might need to do something extra?
So, Doc, if you now have, let's say you have collected the data, then you have some missing values.
Yes, yeah, okay.
How do you decide which one or which method to use to maybe fill in the missing values?
Yeah,
or
okay.
you first calculate the percentage of the missing values, and then you decide from there if you're going to omit those specific columns that have maybe 60 or 50% missing values, or you decide that you say, I'm going to use mean, mode, or whatever to fill in the missing values?
Yeah, that's a very good question. Okay, there's a few components to it. So when you collect data, I'm just going to make a note here, missing data, for all case, partial, and options. Okay, I just want to make sure I've got your question. Okay, so when you collect data, there's a good chance that you won't that you might have missing. It could be the entire record that's got no data, or it could be part of the record that's got no data. And then you have to decide how you're going to manage that sort of information. I think I did have a slide at the end of that previous contact session about dealing with that. So my approach, and bearing in mind that we normally use quantitative sort of survey-based data, so it's questionnaires, and I'll use an online survey as an example because it's quite a nice example of where data goes missing and what you can sort of do about it. So when you run an online survey, what can happen is people click on the link and then they might sort of go past the landing page. And then they sort of look at the first few questions. They think this is not for me, and then they abandon the questionnaire. But what some of the applications will record that because they've clicked past the first page. They'll keep that record in the database, even though there's no data. And one of the reasons for doing that is that there might be a save and continue option set up, in which case they kind of might be expecting the person to come back again and fill out the questionnaire, and they don't want to lose that person and so it's an automatic system that's set up. So that might be one reason why that happens, or it's just that the system records any entry and then it's up to you as the researcher to clean it up once you've got it. So there can be a data set where there's a lot of records where there's no information at all. And what I would do with those is I would delete them. I'd count them and then I'd delete them, and I'd just make a note saying that, say 30 out of the 100 didn't complete they clicked on the link, but they didn't actually complete the questionnaire. The second thing that happens with online surveys is that as you go through the questionnaire, people start dropping out, so that everyone will answer section A. Let's say you've got 100 people answering section A. By the time you get to section B, it'll be 80. By the time you get to section C, it'll be 60, and so on. So people drop out because they just decide the questionnaire is not for them, or they don't, they get distracted or get disturbed. So with those cases, I would also get rid of them, because one of the reasons, depending on the context actually. So if your dependent variable is right at the end of the questionnaire, you're going to, and you need to, when you start doing the analysis with that dependent variable, and there's no data for it, there's no information for it, you're not going to be able to use those cases that have data early on because the dependent variable is missing. So I would also, in that instance, what I normally do is I calculate how many questions people have answered in each section, and then I only include the cases which are sort of complete. And again, I would make a note to say there's a number of cases that haven't completed, but that I'm not going to include those incomplete cases because there's no information for critical variables. And the reason I don't like imputing information if there's nothing to impute from. That's the other thing. So there might be processes that you could follow to impute data where they're missing data, but I don't feel comfortable doing that if there's nothing there to impute from. Okay. Then the other option, or the third kind of scenario, is where there's partial responses for a section, but not complete responses. And that's where you can start to think about options for imputing missing values. So in that kind of scenario, you can say, well, there is some information here. How can I use that information to impute what the person was thinking? So there's, or what, not what they're thinking, what they might have responded rather, which is kind of reflecting what they're thinking. So what you can do there is you can use different options. There's different processes that you can use to impute missing values. So one option is to use the mean. So what you do there is you take the mean value for that variable, and then you put it into the so where there's cases which don't have a value, you can put that mean value in. But that's not seen to be a good, that's not the most effective kind of imputation. There's a process called maximum likelihood that I would normally use for imputing missing values. So it's a algorithm based on maximum likelihood. So there's a program called EQS that I use for modeling. So I'll put the data into that program, and that program does a maximum likelihood imputation of the missing data. So that's the one that I would normally use. But there's a few different versions, and I think there's different contexts for, depending on the context, there might be a better one to use, kind of a better option to use. But those are the couple that I know of. But ideally, yeah, so hopefully in most scenarios, there won't be a lot of missing data, if you're targeting the right sample. But I'm not so sure about, sort of secondary data and records. Most of the secondary data I've worked on has been sort of big national surveys, and where they don't have much missing data there because they have field workers collecting the data and stuff. They've got, it's a big project where they've got funding to have field workers collecting the data. So there's usually not a lot of missing data in those kinds of scenarios. The other problem is where you've got lots of zeros. So you might have data where the data is very, what I would describe as being flat. So there's lots of zeros and not much else. And there's not really a lot you can do about that, because that's what the data is. There was a study where the person was looking at bats and bat behavior, and they were looking for the incidents where certain sort of behaviors took place. But most of the data was zero because the behavior wasn't taking place. So it was, and sometimes in those instances, you just have to describe it, and you just have to sort of describe the data rather than trying to do any statistics with it, because there's no variability in the data. Okay, I'm not sure if that answers your question, but that's yeah.
Yeah, it does though, because even on my side, sometimes we do get maybe we wanna solve a mental health issue or something with the nursing guys.
Yeah.
Then they'll collect data. Then from my side, I need to use that data to use machine learning or AI to come up with some models. So we do get a lot of those issues in the data set that they collect, because they normally collect primary data.
Yeah. I have a colleague who's one of the statisticians that works here, who had, with his PhD, he had a bit of a disagreement with one of the supervisors, because he used an existing data set of health records where it's patient records where they've got information about blood pressure and various other measurements, but there's a lot of blank records in the data set. And the supervisor was saying he should impute the data for those missing cases. But so what he did was he deleted the cases where there was no information. And I think I would have done the same if I were him, because I don't feel comfortable trying to impute a large number of records when there's no information to impute from.
Yes. If the missing records are large, then it's easy to drop. It's always good to drop them. But if where you find that it's just few records and then you can be able to impute, then I think it's acceptable, and there's also literature to support that as well.
Yeah. There's also just to say as well that most of the stats tests that we run have a option for how to deal with missing data. So you can also just run the test without imputing. So if you have, let's say you're doing a correlation and you have a couple of cases where you don't have information for a variable. Let's say you have sort of 150 records, and then 3 of them don't have data for that particular variable. You don't necessarily need to impute. You can just run the correlation with the 147 that you have, because that's still going to give you accurate results. Having 3 missing cases is not a problem. It's when you've got a lot of missing cases that then it becomes a question of why are there so many missing and what can you do about them, kind of thing. Yeah.
Okay. Earlier in the session, you mentioned something about detecting when students use false data. How do we tell if the data they really went and did
Okay, so
data collection, or they
yeah.
fabricated it.
Okay, so SPSS, under this menu here, am I sharing this here? There's there's an option here, identify duplicate cases, identify unusual cases. So if you import the data into SPSS, for example, we can use these. So for example, with that student that I mentioned and I don't think it was her, I don't think she did it. I think it was the people that she applied this. I think she was perfectly innocent in the whole situation. The people that she gave the questionnaire to, it was an online thing. I think they just entered the record sort of several times because they thought that's what she was looking for. And identified them using this identify duplicate cases often and identify unusual cases. So SPSS has a couple of options that you can use to identify, but sometimes you can just look at the data and see it as well. You can just, well, when we run frequencies, we can see there's something wrong with the information and so on. Yeah. So we use different things to try and work out, but this is a very handy function in the program to identify replicates, because it's very rare that you would get a case that's exactly the same, and depending on what you're doing and what you're measuring. But yeah, but we can normally see it. I can normally just see it by looking at the data as well. But I look at data a lot, so it's yeah. In fact, I didn't use this. I didn't actually use this procedure initially. I saw the problem with the data another way. And then I used this to then find all the cases. I could see initially that there was something funny about the cases when I was preparing the data. And I thought, this doesn't look right. And then I used this then to sort of confirm that, basically. Yeah. Yeah. But so that's one option you could use. Yeah. But I think in most cases, it's not it's very, very rare that I think I've only had 2 experiences where students have actually come up with complete nonsense data. So, yeah, and that's I've got another colleague who's very suspicious of students. So she's always seeing she was the one who kind of thought the student had made the data up, and then when we investigated, it was quite an innocent explanation for why the data didn't make sense. It was not, definitely, and it wasn't that the student had made it up or anything. She just entered it in a very weird, she'd just been very, she hadn't understood how to enter the data, and she'd entered it in a way which, when you think about it, could make sense to somebody, but it wasn't the right thing to do. But she hadn't sort of fabricated the data at all. Yeah. Okay. All right. So is there anything, are there any other questions? And is there anything that I haven't covered that you would like to be covered somehow? I've gone through the kind of research journey in terms of supporting students. And then obviously the supervisor continues to support the student once they've handed in their thesis and when they go through the examination process and so on. Which would all, that's part of the process as well. But I think in terms of quantitative research, I think that process applies to any kind of research, whether it's quantitative, qualitative, or desktop. Yeah, but what I would suggest is that anything that you can think about that you'd like to know a little bit more about, which I haven't covered well enough in the sessions, then just let me know, and then we can try and find a way of covering it. And then also, if you want to learn more about quantitative research yourself, because at this stage, so I think some of you are doing a bit of quantitative research, but most of you haven't had much experience with it. There might be some suggestions that I can make in terms of how you might be able to kind of expand your knowledge and experience doing quantitative research as well as the supervisor, rather than supervising a student towards it. All right. Any other questions? Any other comments? Just to mention, I've just really touched on statistics very briefly. So there's a lot of there's many tests, there's many ways, you have many different sort of designs under which you might use a correlation, for example. So to try and cover a range of things is quite difficult, but it's just to, it's really just to kind of highlight some of the things that can work and that don't always work for students, basically, when they're doing this kind of research. And trying to avoid getting to, what you're trying to avoid is having a scenario where the student does a project which is not good enough to be to be published or whatever, or not published. I don't mean published in a formal way, but as a dissertation, that their project doesn't work, and then they're sort of stuck with a situation where they don't have anything to present to as for their thesis. That's what we're trying to avoid. I had a situation yesterday where I helped a student, and then the supervisor sent me an email saying, is the sample enough to work with? Because the student, the only next opportunity is only next year that the student can collect data. So I looked at the questionnaire in the document that the supervisor sent me, and I thought, this is not the questionnaire that I advise them to work on. So I'm sort of panicking, thinking, did I give them, did I provide them with this terrible version of this questionnaire? And then I looked at my own sort of records of what I'd shared with the student, and the last thing I shared with him was what I would have expected the student to be using. But I think the supervisors just sent me an old version of the thing. So I'm just hoping that that's what's happened, and the student hasn't gone into the field with what they had originally, which wasn't actually measuring what they wanted to measure. So you get these kind of situations happening, and you want to avoid sort of bad. You don't want the student to be in the field using a questionnaire which is not measuring what they claim to be measuring, kind of thing. So Andre, so you got a question. Is there like workshops or short courses can we attend? That would be great. Yeah, okay. So we don't, so I have this plan to design some workshops, but every year at the beginning of the year, that's the plan. And then by the middle of the year, the sort of the year has gone sort of pear-shaped, so it's not happening. But we do sometimes do workshops through RCD, which is in the postgrad school. And I'll definitely, if we do something next year, I'll definitely invite you to participate, so that you can, we should be able to do something like that. Okay, at the moment we don't have anything formal. We just do them on an ad hoc basis, or when RCD asks us. And my colleague actually gave up on, he was doing some workshops, but he didn't finish them because I think he was getting frustrated that participants were not able to keep up, sort of thing. So that didn't go very well. So we need to develop something which is more own time, that people can work on in their own time, or take their own time to get the project done. So this kind of module has been focusing on supervising students to do the work. It's not sort of necessarily focusing so much on doing the work itself, but that's where the other workshops might come into play. Okay. But I've got your emails, and I can definitely, if we've got something going, I'll definitely make sure to invite you. All right. So Monday is hand-in date for assignment 2. And then please continue to work on assignment 3. I'm going to send you some materials next week to help you with assignment 3. I think if you weren't here on Thursday, we've got a new due date for assignment 3. It's not much longer after the current date, but there is a bit of an extension for you for that. And I'll send an email, a formal email about that as well. And then I just need to, so with the slides, because I've gone out of sequence with the contact sessions, I'll just go through them and check. I think I'm going to put the slides where they would have been So they might not be quite in the order that I've presented them in the sessions. So just bear that in mind. And I'm going to share the full set of slides with you for this last session. There's lots of statistical procedures and things in the slides, just so that you can get an idea of how the statistical tests are calculated and so on. You don't need to worry about those, but it's just to give you an idea of what kind of options there are and so on. And then also just a final point that I want to make is that not as powerful as SPSS is, we can't do everything in SPSS. So as I mentioned earlier, when I need to do confirmatory factor analysis and structural equation modeling, I use another program called EQS. Another colleague of mine uses a program called Smart PLS. So there's different programs. It's very unlikely that you'll find one program which will do everything. Although if you're working in a fairly simple way, SPSS would probably be fine. It's just that we do, in the work that we do, we're doing lots of different kinds of tests. So we need to use other kinds of procedures. So I've got a colleague who uses what's called the one that the mathematicians use. I can't remember the name now, but it's a program that does longitudinal analysis, for example. So we don't always use the same program depending on what kind of analysis that needs to be done. But if you're doing a general kind of standard analysis, SPSS would normally be fine. All right, I've finished talking. I've talked far too much. And if you have nothing else to ask or to talk about, I'm going to end the session. Yeah, okay, yes.
Are we still going to meet to discuss assignment 3, or this is our last session?
I did discuss assignment 3 in an earlier session.
Yeah, I remember last weekend we met.
Yeah.
Okay.
Do you need more discussion about it?
No, I think we will contact you privately.
Okay. Yeah, I'll also send some notes about that early next week. So just look out for those notes. And if it's still not clear, I'm going to send you some examples of how you could, the kinds of things that you might include in the toolbox, just to give you some ideas. But and then you can, if it's still not clear, then just contact me. Yeah. It's not such a difficult thing to do. It's just you just have to. It's basically what you're doing is choosing resources that you might want to use,
Yes.
and then just explaining why you chose them. And one of the things that might be more difficult is explaining how you would use it sustainably with the students, because it's one thing to give a student something and say, okay, here's a chapter that explains how to write up a t-test. But then the question is, how do you make sure that they use it, and how do you then make sure that they're getting benefit out of it? Because you can give somebody something and they can walk away and never use it, type of thing. So that's probably one of the more difficult parts of the assignment, is saying how would you as a supervisor ensure that the student is going to use it and get benefit from it, that sort of thing. But yeah, and there's different things that you can suggest there. Yeah. All right. But the bulk of the assignment is choosing a couple of resources. The other part of it is choosing something to help yourself. So, but I'll give you some suggestions for that as well early next week. So the kinds of things that you might use for yourself for evaluating students' work. And there's a few things. So for example, that in the first assignment, we used that chapter from Danielle's with the Desiderata for Research Design. So that gives you a set of questions that you can ask, or criteria that you look at when you're evaluating a student's work, for example. So that's something that you could include in that component. But there might be other things that so those are the kinds of resources for helping you as the supervisor. So part of it's helping a student. What do you give the student to help them? And then part of it is what kind of, and I think I've got a paper which I'll share with you, which gives sort of it's like guidelines for for a supervisor that they might use for evaluating work kind of thing. So it's those types of things. I've also got a book, I bought it quite recently on evaluating research. So that would be something that, and there'll be questions in there that you could ask yourself as a supervisor. So I'll try and copy a chapter from that for you and send it to you so that you can see how that looks like. Yeah. Okay.
Thank you.
All right. So it's not that difficult. It's just, you just need to spend the time compiling, deciding what resources you want to include, and then just writing about them. Yeah. All right. Any other questions?
So yeah, sorry, Doc.
Kenny, yes, yeah.
Yeah, just maybe a follow-up on what Andre asked earlier. So do you perhaps, now that UJ doesn't have as yet such a program, do you perhaps know of other institutions that provide, say, for 1 year, such a program to kind of orient or reorient some of us in terms of quantitative studies? Do you perhaps know? Or anything that you can recommend for?
Yeah, so there are, I don't, yeah, the answer is not, I'm not sure. So they sometimes do, so other universities do sometimes offer kind of courses, but they're often quite specific for, and that's what I'm saying, it's sometimes a problem that they're quite specific for a particular procedure or a particular sort of subject, a particular discipline. It's always difficult to find something which is, depending on, and you might be interested in something which is not what's being offered. So let's say, Pretoria might offer a longitudinal analysis course, but you might, if you're never going to use longitudinal analysis, it's not the right thing to go on. So and I don't know how accessible these things are for students outside the university. But I'll do some investigation into that. So, I know there are some courses available on these online teaching, I think it's Udemy or whatever they're called, in those places. Some of them one might have to pay for. I did an R course through one of the through a organization. I can't remember what it's called now, and I had to pay a little bit to do it, but I did pay because it was, I felt I needed to know how to use, or at least understand how to use R. And as part of that program, you would have learned a bit about statistics because they were using examples and so on. But I would sort of avoid R because it's really not that easy to use. So if you're already worried about statistics, and then you have to sort of face this complicated sort of difficult to use software, it's not going to help you get more confident about using statistics. So yeah. I think we really need to develop something within UJ, and it's just as I say, every year the plan is to do that, and then sort of literally within a few months of the year, the sort of the craziness has started, and then it just doesn't happen. Yeah.
No, thanks.
Yeah.
Because I maybe I can talk to you at some point, because I know that where I was before in honors and masters, we would produce data, and it was part of the research methodology. And and perhaps I can reach out to you at some point. Maybe we can have something. Yeah. Okay.
Yeah. So because the thing there though is that it will be within a discipline, and they're not going to invite other people to come in and sort of, if it's for a particular department. So I know in it's one of the humanities departments actually. I think it's sociology. They give their students a course on SPSS, but it's for that group of students. That I don't think they would bring in other students from outside to do the course kind of thing. I think they do it for their honors students, so there are those kinds of things happening within UJ. I think there's also a chap in biology who does stats with his students, but it'll be for that particular department, not for they won't sort of necessarily open up for outside members to participate.
Yeah. Thank you, Doc.
Okay. Yeah. Mfundo, you've got your hand up.
I wanted to say to Kenny, Doc, at the beginning of the year, sort of when institutions opening up for the research proposals, assisting masters and PhD student for research proposal,
I think there is the department, in our department, it's the research development department. It always organizes a workshop, a 5-day workshop in terms of, for example, research design in quantitative or research design in qualitative. I would advise that he attend, because after attending this course, this module, especially this module, I just told myself, because I want to learn more about quantitative. So in 2026, when they send an email for people to attend the research design, yeah, I can attend that one so that I learn more. I believe that UJ, it also, because I've received multiple emails where they invite us to attend workshop and trainings for research design, either for qualitative or quantitative. Yeah, I was just suggesting that he should look at that as well.
Yeah, so we do, yeah, so UJ does offer a lot of kind of general type of workshops for students and staff as well. But it's just, I think the other thing I'll just also suggest is that if you're going to, and I've kind of had this problem myself personally, is where you attend a course and then if you don't use it immediately, you're not going to be able to apply it in sort of a year's time. So if you don't sort of work on it straight away, and that's also another issue, is because if you're doing, let's say, for example, you do an analysis course in January, but you're only going to do your analysis in October, it's going to be very difficult to remember all the procedures and things, and it's not really very helpful. But I think that's also another reason why you don't see those kinds of courses very often, because for us, there's people needing to do research all the year through. So it's an ongoing thing. So it's not like there's a best time of the year where you could present a course where most people would benefit, because some people might need it in January, other people might need it in December, kind of thing. And it's not really, it's difficult to get the timing suitable where it's going to be most convenient for students. And also you don't want them sort of doing a course 2 days before they have to hand their analysis in. So that's also a sort of tricky thing to manage. In an ideal world, when I did my PhD, when I started, they identified what skills you would need to be able to do your research, and then you would sort of do courses on those skills that you needed, and then after that you were sort of pretty much on your own. But the university that I did my PhD in was very well resourced, so they had the capacity to do that, but not all universities have that kind of level of resources to do it. So in an ideal world that should happen, but the reality is somewhat different because we're all at different stages and so on. Okay, right, but onwards and upwards.
So thank you, Doc, and Mfundo, thank you so much. I did actually for 2 years. I think, like you said, it's a matter of practicing. I need to do it. So yeah.
Thank you. You have to. Yeah, I think it's like, it's difficult to get back into some. I find this with qualitative, with using Atlas, for example, because I've used it before, but I don't use it for long stretches of time. So and when you have to go back, and I've sometimes tried to show a student how to sort of import their data and do some coding and stuff, and then trying to remember how everything works is really quite difficult. Yeah, and it's you kind of remember eventually, but it's not, it takes a while to get back into it, and it's not it's not really. I think if you're using something all the time, it's much easier to remember what to do. But even, I use SPSS all the time, but there's certain functions that I still have to go back to the manual to remember, because I might use them once every 6 months or once every year. So in fact, I had a meeting about a manover, and I never do manovers. So I had to quickly look in the book to work out what the results mean, to help somebody else to interpret them, because it's not something that I do often at all. So it's what we kind of repeat and do often, we know better. than stuff that we don't do, that we do really and every now and then. Yeah. All right, good. So thank you very much, everybody. I might not see you again in a contact session, but if you need any help, just send me an email. And I'll be in touch early next week with I'll probably start sending you a few emails just with different sort of covering different issues. But good luck with your assignments and good luck with your other courses that you're doing. I know you're doing these other courses as well. So I hope those are going well. And yeah, and then if there's anything that you think about which you'd like to discuss, which might be useful for the group, I'm perfectly happy to meet on a Saturday morning going forward if that's necessary. So if there's something that you feel needs to be discussed urgently, we can meet if you're willing to as well. All right, good. I'm going to stop the recording. And yeah, yes, good luck with the last push.